Blanco's YouTube channel. In this tutorial, I'm going to go over all the main objectives that are outlined in the exam content guide for the SAS 9.4 Advanced Programming Performance-Based Exam. So there's 13 main objectives that SAS provide us to go over with, and they say that all 13 main objectives will be tested on every exam. We'll also go over every sub bullet point that's on the exam content guide through examples and primarily using the SAS help library. First, I'll just also go over some administrative things like how much the exam costs and where you take it. So the cost of the SAS Advanced Programming Performance-Based Exam is $180. The certification never expires. Just for example, I know with the AWS Developer Certificate, you have to do a recertification every 3 years. That's not the case with this version of the SAS 9.4 Advanced Programming. But there may in the future be an updated name for it where it's a different certification altogether. For instance, there's a SAS 9 Advanced Programming certification rather than the SAS 9.4 Advanced Programming certification. And the performance-based exam can be taken online. So there's the proctoring is done through a company called Pearson, and you'll have to, about 15 minutes before you take the exam, set up your microphone and environment and camera, and you sort of give them a shot of your room, make sure there's no paper or anything out. And yeah, it's fairly straightforward, fairly standard like any online proctored exam. So the structure of the exam is performance-based and multiple choice. Performance-based makes up the largest chunk of it, and will take, it took me about 2.5 hours to do the performance-based part, and I really took my time with it. And then the multiple choice was a fairly short section. With the performance-based, you can also don't have to finish a problem before moving on to the next one, but I did it that way. I could have come back and double check some things. But yeah, you can sort of move between questions or problems in terms of the programming tests that they give you. You can search SAS documentation in your exam session if you're unsure about anything, and I would use that sparingly. If you really get down all the points that are in this video and everything they give in the exam content guide, you should be fairly comfortable with most things, and only perhaps have to look up a couple of things maybe for some clarification. But I don't think you really want to waste your time looking through documentation during the exam. And in general, just the instructions that Pearson VUE gave when I took the certification were very clear. And it's fairly straightforward, just like any online proctored exam. So let's set up our environment, and we're going to be looking for SAS On Demand for Academics, which kind of replaced SAS University Edition in 2021. Once you get to the page here, you want to click Access Now and sign in. If you haven't already, you'll have to sign up for an account, but if you already have one, it's free. I have one. You just type in your email. Accept the terms and sign in. And yeah, there's a lot of options in here. You can get information on SAS certifications, which is what this video is about, but we're just going to launch SAS Studio and get started in there. And so what I'm going through in this video is the Advanced Programmer content guide. There's 3 sections to the content guide, which is proc-sql, essentially accessing data using SQL and SAS macro processing. So we'll be talking about the SAS macro language, and then advanced techniques, which is kind of any other stuff that's on the test, arrays, hash objects, proc-fcmp, and the format procedure as well. And also there's some introduction to regular expressions in SAS. And the full content guide can be accessed here. This is linked in the description of the video. But in this video, I'm going to be going through every single one of these bullet points and sub-bullet points, and giving an example using the SAS help library built into SAS Studio, to hopefully prepare you for an understanding or a refresher on all of these different bullet points that are in the exam content guide. And as the content guide says, all 13 main objectives will be tested on every exam. The additional details provide additional explanation and define the entire domain that could be tested. So with that being said, let's jump back into SAS Studio, where I've already copied and pasted this outline. And then I'm going to start going through each one of these with an example. So to start out, we'll do this generate detailed reports, which we're doing this heading, generate detailed reports by working with a single table, joining tables, make myself a bit more room here, or using set operators in SQL. So let's use proc-sql to perform a SQL query and select columns in a table with a select statement from clause. Okay, so again, I'll be using, for almost all my examples, I'll try to use the SAS help library. It has a lot of toy data sets you can use. Some you may be familiar with, baseball data set and Fisher's Irish data set are some of the more famous ones, if I can find it, this one, that are in this data set. If you're unsure about, if you want extra details on any of the data sets, you can always do this proc data sets, proc contents, data equals SAS help dot baseball, and you'll get information like the format of the columns, some more information about the description or the label. So, if you just look at this variable name or column name, you might want to look at here to know more about what it means. So it's baseball, details of baseball, Major League Baseball from the 1986 season, and just a lot of data about different players. It's a toy data set that we use, but again, chances are if you're interested in taking advanced programmer, you're familiar with proc contents, but it's still very useful. But that's a digression, but a useful digression. So let's carry on with proc-sql. So I tend to put the no print option in when I use the SQL procedure, and I may not format my code consistent with the way that SAS Studio does. If you want to use the SAS Studio code formatter, you can just click this at any time and it will do it for you. It's quite a handy tool, but I tend not to use it. I'm going to create table. I'm going to call this baseball 1. And I'm going to use the select statement to just select a subset of columns. Not going to take them all for this example. So I'm just taking these 3 columns from SAS help.baseball, the one we were just talking about. And this satisfies an example where we use proc-sql to perform a SQL query, and we select columns in a table with the select statement. and the from clause. So it's assuming there's no syntax errors, we should be good. Cool. Yep, so there we are. Always good to check, yeah, I don't have any errors in there. And as our output data, just these 3 columns, the number of at-bats for each team. We can also, in SAS Studio, we can click on this and look at the label here, times at-bat in 1986. And yeah, so, and the team name and the player's name. So player's name, cool. All right, so let's move on to the next bullet. Create a table from a query result set. And this kind of is captured by this and will be captured by a lot of the other ones we do, so we'll just put that there. Next, we'll create a new calculate column. Okay, so this will be something different. I'll just use this as the basis though. I'll just copy and paste in the interest of time. And we'll do baseball 2, and this time I'm going to make use of star. So this will be to select all columns, I think it's 27 columns or variables that are in this SAS help baseball data set, and I'm going to make a new one. And I'm going to call it, well, actually I'm not going to call it anything first of all. So it's CR home divided by CR at bat. And yeah, so that'll be it. So we're creating this new column that I made up, that is the number of home runs at bat times by 100, so like the percentage of home runs a player would have for their time, for the number of at bats they have. Yeah, so let's run that. And yeah, I selected all the columns, so we have all 25 of this. And then our last column will be our new one. And we have the kind of this ugly thing going on here because we didn't give it a name. But you can see we have, someone has around 4% of the time they're at bat, they hit a home run. Some players have below 1. A player here has 6% of the time they're at bat, they hit a home run. So yeah, so just an example of creating a new calculated column. Okay, now next we'll get to a more useful version of this, which is assign an alias with the as keyword. Okay, so I'm just going to use the same thing, and I'm just going to call this as CR home run purse. Yeah, so home run percentage, and I'll call it a different name. So all these different data sets that are used in this tutorial don't override each other, and you can look at them easily. So run that. Should produce the same result, just that we have a real column name using the as keyword. Okay. So now let's move on to looking at case logic. So this is for cases where you might want to create a new, where you want to create a new column or variable, as we often call it in SAS, that is conditionally based on another column. So let's keep on working with the baseball data set, and we'll call this baseball 4. And again, we'll take everything and have this CR home run purse column, and we'll put a comma in there so we can add in this case logic to make the last column. So yeah, I'm going to use the case statement, and then again You can use the formatter to have the syntax that's recommended by SAS Studio, but this is the syntax I'm going to use. So I'm going to do a when statement option for when calculated. So I have to use the calculated keyword, which is referenced further down. I have to use the calculated keyword to access this this column because it didn't exist on the data set we read in the SAS Help Baseball data set. So calculated CR home run purse is greater than, let's say 5, then high. And then gonna want something similar for middle home run percentage. When calculated home run purse is less than 5, and oh wait, sorry, and calculated home run percentage is greater than, let's say 1, then we'll call that medium. And then everything else we can use the else statement option. We'll just say else low. So, and that will be everything that is less than or equal to 1. And then also we have to use the end as option to name our name this new column we're making with the case logic. So we'll call it CR home run class. Okay, and yeah, sometimes another option I didn't mention to use is the feedback option, just in case you do have an error in the log. It gives you a bit more information to help troubleshoot whatever you've done wrong. So yeah, I'll just add that in for this one. I'll give you a peek at what that looks like, assuming there's no error. Okay, so we've added our new CR home run class. Oh, didn't mean to do that. Okay, and you can see we've got some low, medium, low below 1, low below 1. Oh, found a high. Someone had a home run percentage of 6%. That was in the high category. Someone else there in the 5. And yeah, so just an interesting example. I was going to show you the log to see what using the feedback option here is the first time I've introduced that. So here we have star, and feedback gives us all the information on what we're accessing from a particular table. And yeah, it just gives us a bit more information for scenarios like that. So yeah, probably just get rid of that. Okay, so now let's move on to retrieving rows that satisfy a condition, and we'll move on to using another different data set here. So proc-sql, no print option. Yeah, not mandatory, but I generally use it. Create table. I'm going to call this one cars 0 as select, and I'm going to select everything from SAS help.cars. Again, you want to know more information about the cars dataset, just use proc-contents. And here's where we're going to add in the where clause to make a subset. So we're going to do where type equals sports. Now I happen to know, that this requires the proper case with the uppercase starting letter in the string. There's options you can use here in SAS. You could use the uppercase function or the lowercase function to make this not having to have this ugliness here, but I'm just keeping it simple for this example. So I'm just going with what's in there. Yeah, so here we are. We're just taking the where the type is classified as sports, and that's our subset based on that where clause. So we got 49 rows, and they'll all have sports. Conversely, we could do something like this. We could use where type not equal sports, and then we get everything in other classes. Where are the SUV, sedan, wagon? There's several of them. So, yeah, so just an example of a simple subset. I'll leave it with that example. Okay, so now let's subset data by calculated columns. So we talked about what calculated column is in the baseball dataset examples. Let's add one to this. I'm going to call it the GB price, which would be the British pound price, and I'm just using a made up exchange rate of 0.78 to the US dollar. The MSRP is in US dollar in this data set. And I'm going to call that as GB price. Cool. I'm going to get rid of the where clause here because we're not using it for this one. But we could, you know what, we'll use it. Yeah, let's use it. And we'll use the calculated keyword to use the where clause on the GB price we just made. So we have to use that calculate keyword. Let's say less than 40,000. So that would be less than 40,000 pounds. So yeah, we subsetted the data with the where clause by using the calculate columns. Okay. Yeah, and as you can see, there's still a lot of the data set that are there. For example, if we conversely did the GE to greater than or equal to 40,000 pounds, we'd have a much smaller, we got the sort of high-end vehicles. So yeah, there's a couple of examples of subsetting data by a calculated column. Okay, so now we're moving into join tables, inner joins, full joins. We'll look at the coalesce function, right joins, left joins. There's a couple of ways. We'll start with inner joins since it's first. There's a couple of ways you can do the inner joins in proc-sql. I want to show you them. Depending on your background, if you're coming from another flavor of SQL, this is probably not the way you would do it. But if you're coming from using SAS data step, this might be a way you don't mind doing it. Either way is fine, and they're both fairly straightforward. So the first example I'll do is I'll call this join one as select a dot star. I don't have to use A here. I'm going to use A as an alias for a table, but you could use anything you wanted really. If perhaps you want something more meaningful than that, but it's just easy to keep track of. So I've used A and B just to keep it nice and simple. So I'm going to go from one data set, which is called SAS help.prd sal2, which is some sales data. I have to put the A down so we know that this table references that A and we're taking every column in that table. And then I'm going to use SAS help dot US data B. Um, and we're going to use the where clause to say what we're joining on essentially. So a dot state. These two tables have a column in common, and that's what we're going to join on. So a lot of times I've seen Venn diagrams used for SQL joins, and the same is true in this one. So with this inner join, if you were thinking about your two circles in a Venn diagram, you'd be thinking about the inner part, the bit where they overlap. And so basically here we've got this column from table B that adds in the population density. You know, you can look up 2010 people per square mile for a particular state, which is what we joined it on. And maybe that would be useful information for your sales data. Maybe not, but yeah, there's lots of different states. You know, so you can see the population density was added. You know, as part of this inner join. Okay, so you can do this another way. Probably the more, I would say the more, for me, the more conventional way to do it would be the following. So instead of, we'll call this join 2 to differentiate the sort of the two ways you can do an inner join. Be the same up to here, and then you do from SAS help PRD sal2A, and you'd say inner join. Use the inner join statement option to SAS help.US data or table B, and instead of where, you'd use on. So this may look a lot more familiar to anyone who's coming from a SQL background. You know, in I don't know, MySQL, SQLite, or Microsoft SQL Server. You know, whatever. This may look a lot more familiar than using this. So, and you'll get the same result. Just sort of two different ways you can do it. And again, we got the same result. Just our one column from table B, and that's the population density, and all the sales data comes from table A. Yeah, so that's a couple of simple examples of an inner join. So now let's look at a full join. And first, I'm going to do an example of the coalesce function to give you a better sense of what that is, and then use the coalesce function in a full join. So let's call this so we're going to do proc-sql. Again, I use the note print option, not mandatory. Create table. Let's call this coalesce example as select next page, next line, sorry. State name as state, comma, and now we'll use the coalesce function. And I'll explain more about what we're doing in this example. So there's a column in the US data set we referenced up there called reps, and it has several columns called reps. It's got reps 1910, which is the number of representatives in the US House of Representatives that a particular state in the US had in 1910, in 1920. Well, let's put one from 1940, one from 1950, and one from 1960. So what's the coalesce function going to do here? Well, let's take a look at this data set in the SAS help library. Then we'll look at our results too once we finish that. So we're looking for the data set US data. It's somewhere down with the U's. There it is. Okay. So we have these density such and such. But this is a good example because when a state, for example, Alaska is the second row, it wasn't a state in 1910, so it had a missing value. It had a missing value in 1920, 30, 40. I'm guessing this might be Hawaii, or sorry, no, this may be a territory that still isn't a state. But this is Alaska. It was a state by 1960, and it had one representative in the U.S. House of Representatives. So it gets one. And what the coalesce function will do here is if you put coalesce 1920, 30, 40, 50, 60, it'll take the first non-missing value, so it'll take 1. But if you look at the state above it, Alabama, if you did the same thing, it would take the first non-missing value, which let's say we did 1910, it's 10. It's not going to take 9 or 8. So hopefully that gives you a good sense that it happens to be that in this data set, the first 2 rows give you a good example with Alaska having these missing values. So, okay, let's close that. And so yeah, let's close that. And so coalesce reps, all these reps. We'll save that as reps. And yeah, and we'll just put from SAS help US data. Okay. And quit. Okay, if you run out of room a bit like I am, this would also be fine. This is probably the way I'd set it up, so it's nice and easy to read. Cool. And so I've got a bit off track. This is just a coalesce example. We haven't actually done a full join, but I just wanted to highlight this, and we'll see here. Alabama had that value from the 1910, the 10, and Alaska had that 1, and you could go on down. Hawaii, I think, became a state at some point in the 1950s, so it would be a similar example to Alaska. Yeah, so just a cool little example there. Right, so let's move on to doing a full join. So proc-sql no print. Create table, full join. as select and oh yeah, and we want to use the coalesce function too. So we'll coalesce the first valid one of these two columns from the different tables. Map ID name, which is going to come from table A, and state name, which is going to come from the second data set. As new state name. And we're taking that from SAS help library, of course, and the table A is GC state, and the table reference is A. Full join, so we're doing a full join to the US data set that we've been looking at a little bit, which has reference B, and oh, it's trying to make me put between the and we need to do this on a common reference, and since we're using this map ID name, state name, that's what we'll be doing the full join on. And also gonna, just to throw it in there, I'm gonna use the order by statement option. And again, we're going to use the calculator keyword just to show another example of that. And we'll do it on this new state name. So we'll we're sorting the data set. This is basically doing what proc-sort does in base SAS. Okay, so yeah, so this is a full join. We're using the coalesce function to take the first meaningful occurrence of these guys that reference the same thing, and then we're also doing the full join on those. So yeah, what's interesting here is an example is that you have a you have some places like Puerto Rico, which is a U.S. territory, or Quebec, which is a Canadian territory, that have some missing data. And if, oh, sorry, our column that we made is all the way at the end. So let's just look at a few of these. So just randomly pick a couple of columns, and then the column we made that is sorted by is actually at the end. So so here's our new state name, and so we took the first occurrence between these two data sets, the map ID name and the state name, and one of them didn't have the state name, which came from US data, didn't have the Canadian data in it, but it took Alberta, for instance. I think American Samoa was probably in it, or British Columbia. It took the first non-missing occurrence of that, and that came in useful. So we got British Columbia in there, even though we're missing some of these columns. But because it's a full join, we're essentially taking everything from the two tables. So yeah, that might be an application of the coalesce function and a full join. So now let's look at a right join and a left join. So proc-sql, no print, create table, right join as select. We could just use this example from here again. We'll just cut out the coalesce function. Yeah, let's just do that to simplify this. So, and again, instead of using full join, we're going to be using right join. So if you're thinking about this in your Venn diagrams, you're taking everything that's on the right side of your the right circle and the center, and we can compare and contrast what that looks like with a left join. So here we're getting everything from the US data set, and you can see this by the fact that we've lost our Canadian territories, and we just have US states. Now if we take this same snippet of code, changing the name of the data set doesn't change anything, but if we change this to a left join, now we should get everything from this GC state, which has the Canadian territories in it. And we do, so we see Alberta's back in there. We have several more rows. I also think some of the US territories were lost in the other data set, so we have Guam now too. So yeah, just a quick example of a left join. You need some kind of columning common, and then again, same for the right join, and then we talked about the full join and the coalesce example, and the inner joins, and the two different ways we can do that in the SQL procedure. So cool. Let's now jump into combining tables using set operators, like union, outer union, except, intersect. So, okay. So, let's start out like we usually do. Proc-sql, no print. Create table, union, example as select. We'll take everything from this table. I'm actually going to do take a data set, a subset of a data set, and then put it on top of another data set. So we're taking a subset of the SAS-help.prd cell data set using the where data set option to take a subset. Where the state equals California. And then I'm going to put on top of that, using the union operator, So basically we're going to stack the rows from each select statement. So from another select statement, we're going to have stack this on top of the first one. So we're selecting everything. For again, we'll use the same data set, but I won't just put California on top of California. I'll put Quebec on top of California. And yeah, again, it's useful, especially if let's pretend this wasn't a subset of the same data set. If you had two different data sets that have variables and columns, I use the words interchangeably in SAS. If they had columns that were the same, but they were two different data sets, not a subset like in this one, you can see how this union operator would be useful to stack data sets on top of one another. So cool, and we'll look at how you can use also do this with an outer union here in a moment. So let's take a look at this. Cool. So results. Oh, we have an error. Sorry. Missing equals for where option. Oh yeah. Oh yes. Sorry. Yep. Syntax error on my part totally. And I put it in both of them. Okay. So let's fix that. Cool. So yeah. So now we have Quebec. All the ones that satisfied the state equals Quebec on top of the ones that had state equals California. Okay. So let's keep on going with an example of outer union. Let's do the outer union example. Actually use the same code as a starting point. There's two things we can do here in terms of syntax. You can do outer union. So we can use outer union, which produces which is an option, or we can do achieve the same thing by doing union all. But they're calling for the outer union syntax, so I'll just use that. And I'll I'll stick with the subset of the PRD cell 2, and then I'll just there's another SAS help library dataset called PRD cell 3. And yeah. So we'll notice we have like a column here from one of them that from one of the tables that was with the union operator, you're putting all the observations and on top of one another. With the outer union one, where we have an extra column here, it just gets dumped on its missing value in with the outer union operator. Oh, and we'll call this outer union example. Okay. Let's keep on pressing on. Again, we could have used the union all operator, and this with the outer union includes all observations from these two data sets. This subset of PRD cell 2 and PRD cell 3. So let's look at using the except set operator. I'll just use that as a starting point again. So let's, in this case, do except one, where we say PRD cell 2. Instead of the union set operator, we'll do except PRD cell 2, where state, we could do Quebec, I'm just going to do California. So in except 1, we're going to exclude, we're going to take this data set, except there's simpler ways of doing this, but this is an example of the except operator that I could easily think of using the SAS out library and a data set we've just been using. So here we're going to take everything except the ones that are in the state of California. And so you'll notice, you can do the filter query here where state equals California. Yeah, so you don't get any output. Cool, and just, to convince yourself of what you're doing here, we could just throw in another one, also using except. We could call this except 2. We could say where state not equal California. So we're taking everything from this query here, which is just the same data set, and then excluding this subset of the data set where everything that's not equal to California. And in except 2, we'd expect to find just the ones that have the state of California. So here we know we're good. It's a much smaller data set. Cool. So yes, not an efficient way to do what we're doing here, but a good example of how the except operator works in proc-sql. So now we'll keep on working with the same data set, and we'll look at the intersect operator. Cool. So again, we're going to be doing one query here. Call this intersect example. Okay, and we're going to be using intersect. Cool. And again, we'll work with this PRD cell 2 data set. Yeah, we'll use the where equals data step option. Yeah, let's use something different. We'll do, if I can spell it correctly, Saskatchewan. Saskatchewan. Yep. And then we'll do intersect state in, since we already have California there, we can do that. Let's add in another US state, Oregon, and then so I spell it correctly, I'll take Saskatchewan. And oh, I need another parenthesis here. There. So yeah, we're looking at the intersection again. Pretend, if you will, we're not using the where equals data set option here. Our first query here is just some data set where there's just the state of Saskatchewan, and then we have another data set, another query here where we have several several different states here, and we're just going to see where the two of them intersect. So we're just, again, you could get this same result because of the way it's written from in a much simpler way, but we just want to see how the intersector operator works. Okay, so here we get every Saskatchewan, and then if we we're getting every Saskatchewan that's in this query down here. Now, if we were to do this, we would get a different result. So now we should get the we should get all the results without Saskatchewan included. So cool. So yeah, that's just a basic intersect example to introduce that. But yeah, let's move on to the order by clause. So we've got away from the joins and the combining tables with the set operators. That was one bullet, but it's quite a lot of stuff. So let's take a look at something we did earlier. I'll just go ahead and copy it where we looked at the cars data set. And we made we added that calculated column called GB price. I'm just going to copy this and use the same code down here. So here we go. We can call this cars 3, I think. So yeah. It doesn't really matter. I just don't want to, if I want to run the whole tutorial in one go, I'd rather not overwrite other work library datasets. So yeah. So we made this dataset where we're reading from the SAS help cars dataset. We made this column variable called GB price. And then we also made it a subset. We based on whether calculated GB price was less than £40,000. And now let's take a look at the order by clause. So if I wanted to sort the table, I can use order by, but I want to use it on my calculate column, the GB price. So I have to put in this calculated keyword again. And so there it is. And I could sort this in 2 ways. So this will be the default. If you take a look at this, and it's going to go from the cheapest car, which is as you can see, the MSRP is the lowest on this one, the invoice is the lowest, and the GB price is 8,000. So this is the default. It sorts in ascending order. But perhaps we wanted to look at it in descending order, and we'd use this desk option, which sorts row in the table name by the values of each order by item in descending order. So again, we could sort on multiple values here. We could sort on something else too. But yeah, we'll just do this for now, and I'll stick with the descending for this one because I think it's a bit more useful for this query. Yeah, so we're starting out. We're looking at the top, most expensive vehicle under £40,000, which is what this GB price is meant to signify. And since it's multiplied by a constant, it's the same. It's the most valuable MSRP under 51,000 ish. So okay, and now we'll just use the same SQL procedure code here for our next example, which I'll call cars 4. The work library data set I'll call cars 4. And we'll say MSRP, same thing, GB price. But we want to assign labels and add formats to columns. So how do we do that? Well, it's pretty straightforward. in proc-sql. So to add a label, you can just put quotation marks right here and say MSRP. How do we want to phrase this? Maybe in pound sterling. Cool. So that'll do nicely there. And then for format, we just put in this format statement option, and I'm going to use a bit of an obscure format that you may not be familiar with. So similar GBP 32.2. Okay, so I'm using this format. There's a lot of ones used. If we looked before we do this, let's go back to our old friend proc contents. Data equals SAS help cars and run. Okay, so if we looked at this SAS help library dataset we're using, you'll see all these formats like $8 on the monetary ones, and some labels that are useful: miles per gallon, highway, miles per gallon, city, and so on. Weight, pounds. So just some, with the contents procedure, you just get some more info. Cool. Just mentioning that. Well, you know what? We'll look at it with cars 4 after I've done this. So here we've added, back to the purpose of why we're doing this, we're assigning a label. That's the MSRP in pound sterling. And that format, again, it's a bit of an obscure one. But hopefully you'll see what it looks like in the results. So cool. Yeah, so if we can look at this, I've got my label now, MSRP in pound sterling, this weird format here, but what it looks like when you look at the data set is you get this the pound sign for the British pound sterling, and that's 39,000 and so on pounds. Cool. And then you could also look at this with proc contents and just see the difference. So yeah, let's look at that in the contents procedure. Yeah, so we have this, again, it's a bit of an obscure format. More common in the US certainly is $8, and then the label we've added. So there we see how simple it is to just add your format and your label in proc-sql. So I'll delete this proc content stuff. Cool. So now we're going to move on to the next section with some more bullet points. So this part is going to be generate summary reports by working with a single table, joining tables, or using set operators in SQL. Summarize data across and down columns using summary functions: average, count, max, min, and sum. So let's start off, and we'll just carry on hanging out in this cars. Yeah, data set. I'll just at least copy this part. And yeah, let's take a look. So we'll call this cars 5, I think is where we're at. And we'll say create table as select. Now I'm going to use distinct here. So we want to get the distinct values for something, and we're going to sorry, before we do that, let me just do this. Let me do the max one first. So let's just look at max MSRP. So we're going to add a max MSRP as max MSRP. So I'll show you one way you could use something like this in a query. It's not necessarily, intuitive that you might want to use this, but perhaps you want a column in a query that has the highest value constant. If you did, this would do that. So you see what I mean there. So we're just going to have one column that is the maximum MSRP the whole way down. Probably not something you certainly don't want to be putting that in a data set, but maybe in a query that might be useful somehow. So here's what that would look like, just for an example of how the max MSRP max function works. So MSRP is a column that exists or a variable that exists in SAS help.cars. And I put it first ahead of all the other columns. So we'll see what that looks like. So yeah, we have this max MSRP is there. It's constant the whole way down. And you could do the same with any one of these functions. The count would be the count of columns in the data set. Min would be obviously be this lowest price. For this example, sum would be the sum of all the MSRP. So perhaps that might be useful in some way for your like inventory on a car lot. If that was what the data set was about. But where these are perhaps more useful is with the group by clause. But let's take a look at how we might use these as well. If we said select distinct. So if we use distinct, we want something unique. We said max MSRP is MSRP. Maybe we have a query here where we want to see, perhaps we want to, sorry, I'm just going to do a subset of some columns, make model, MSRP, perhaps we want some limited information. Let's do max MSRP minus MSRP, so I guess the difference between the two of them as max MSRP diff. Let's call it 6. So we see here, you can use this max function. I used it in 2 places here. Same goes for them. You replace this with any of these functions, min, sum. And so I have here I have the difference between the maximum price, which may be useful. You may not want that constant, but you can see how this isn't a constant and might be useful just for you to have in a sort of lookup, a table you query. Not lookup table. Yeah, so that's another use for it. But then I think probably most important is to use this in the group by clause. I'm not sure why I used distinct here. When I made some notes before I did this, I think you get the same result. Yeah, you would. So you don't need to use distinct. Where you might want to use distinct for something like this is if you just wanted to look up the particular make a model of the maximum. Again, in that scenario, you get that too. Cool. Yeah, I don't think that. I'm not sure why I put the distinct in my notes. I'll just get rid of it. Okay, but we want to use the group by clause, which is probably the more useful way you'd want to use these functions. So I'm just going to copy this as the basis for my one with the group by clause. We'll call this car 7. And again, we'll select max MSRP, make, model, MSRP. We'll get rid of this one. Origin. Okay. From SAS help.cars, and now we do the group by clause, and we'll be using origin. So we're sort of grouping them by origin as like region in this data set. This SAS help.cars data set. So let's take a look at what this looks like. So yeah, you can see sort of the more usefulness of it here is this max MSRP is specific to origin Asia, or origin USA, or somewhere in the middle. Origin Europe is the really high-end one. So perhaps, if you use the group by clause, that could be more useful. And then and then if you wanted to, you could use the having clause, which is pretty useful. I'm just going to use the same. Get rid of origin. But let's say having. MSRP equals max MSRP. And in this instance, we should get a one row table here. So for instance, running a bit slow there. So we get the one, for some reason you wanted that one row query to find out which vehicle had the highest MSRP. There you go. You probably wouldn't need to have this row column in there. So, but anyway, yeah, and if we so I used the distinct keyword earlier, unnecessarily. But if we wanted to again let's keep on going with this same SAS help.cars dataset we've been using. So if we wanted to just have a distinct keyword to eliminate duplicate values, and we'd use distinct. Let's say we just wanted to see a table of all the different makes that are in this data set. Yeah, we'll get rid of that. This would give us that. So we just see what, in this query, we only want the different make of vehicle, and this will eliminate duplicate values for the same make. So as you see, we got unique makes like Acura, Audi, Volkswagen, Volvo, and so on. So cool. Yeah, so let's keep on moving down to constructing subqueries within constructing subqueries and inline views within a SQL procedure step. And here, if I was, not going to use the no print option, this would probably be the place I wouldn't use it. So we'll create another table. Create table, again we'll make it cars, and it'll be cars 10. Cars 10 as select. We'll take all the columns from SAS help dot cars, and where, so again we're gonna have an inline view down here. We're gonna do a subquery with the where statement option, where MSRP greater than, you could do it this way, or GT, whichever way you want. And now I'm going to do this inline view. So we're doing another query here. Select average, another one of those options we've been using max, but you know, we could use this one too. MSRP. Select average MSRP from, again, it's from the same data set, but you know, it could be from a different source. Maybe you know, I'm just using this because we all have access to it, and it's very easy to just look at. But this could be some query from a disparate data source, and then you know, you could be making this inline query here. Yeah, so basically I'm saying we're creating a table here that takes everything from SAS help cars where MSRP is greater than this average I took here from this cars dataset plus 1,000. So yeah, I could have just made it the average, but I just figured I'd add on a bit more. Okay, so let's take a look at what this looks like. Yeah, so we have a subset here where the MSRP is above the average plus 1,000, basically. That's what our subset is, of 149 from the 328. Yeah, we could do all kinds of things, but that example just gives you a good starting point. So now let's look at making a subset data by using non-correlated subqueries. So what does that mean? Well, yeah, well, I'll give you an example that hopefully illustrates what exactly this would mean. So proc-sql, no print, create table. Let's call this non-core sub q. And yeah, and again we'll be using the SAS help library as with all these examples. As select a dot star b dot density 2010. So this is from the US data set. C dot average density, and this is from a query I'm going to be making down below. I'm making up this you know, this column is one I've named myself, or I'm going to name myself. Okay, so from SAS help dot PRD cell 2, and that's going to be the A reference here, okay? And then I'm going to take SAS help .us data B, and now I'm going to do what I did up here and have an inline query to make table C. So again, there's lots of different ways you could go with the syntax. Really, this is the one I'm going to go with here. Select state name, comma, average. I'm using that function again. Density 2010. As whatever I called it here. From this same data set. And then I'm going to make sure I call that C. Oh. And then I'm going to do where option a dot state equals b dot state name and c dot state name equals b dot state name. And just going to order it by, since we've been talking about this too, b dot density 2010. Okay. And that should do it. Hopefully there's no syntax errors. There was a lot going on there. So let's run that. Cool. Yeah, it's looking good. So what are we doing here? Yeah, so we did this this average density 2010, and then we have it from the lowest population density in 2010 for all these different sales location data to the most populous. So we're using non-correlated. These were non-correlated subqueries, since this is quite a different data set in terms of the PRD cell data set, and then using my non-correlated subquery here. And also it's a good example to see three different tables being joined together here with the A, B, and C references, or with C being a subquery. So, okay, let's look at referencing an inline view with other views or tables, multiple tables. So let's head back to cars for this one. We'll call this cars 11. And we'll select everything from SAS help.cars, where MSRP between so we'll look for stuff near the middle. I guess you could pretend this was like one standard deviation from the mean. Not that it is. It's just an arbitrary number, really. and then so we'll add a second inline view here. Sorry, let me get away from putting spaces. I think it's probably better to have it something like this. Yeah, that looks respectable. Again, if you don't like the way I'm doing this, you can hit this format code button and it'll do it the way that SAS Studio wants you to do it. Make this plus. So we're going to make this, we're going to take everything in SAS help cars between these two inline views. So multiple inline views. Again, we're, for the purpose of making this a usable example, we're using the SAS help library. We're actually using the same data set, SAS help.cars, but again, it gives you that sort of base example of what you can do here. And again, just in this particular example, there's certainly easier ways to do this, but I just want to give an example where you can use these two inline views. Okay, so so we get a subset of 24. So everything that's basically close to the average price, or within 1,000 plus or minus the average price. Okay. So yeah, in some ways you can think of these, I often think of these as like a temporary table. So I have the main table here, but I have like a temporary table that's going on, in between as part of my SQL procedure, or my subqueries are sort of temporary tables. Cool, so we've actually been using a lot of these data set options here. I've been using where, which isn't in this list. I've been using where equals all over the place. But let's look at some of the other ones. So keep equals, drop equals, rename equals, obs equals. You won't have to go far here to see where I've used where equals. Or maybe you will actually. Just scrolling up. Yeah, so I used a bunch here just to sort of create some working examples. And yeah, back down to here. Let's take a look at some examples using other data set options. Yeah. So proc-sql, print, create table class 1. So I'm introducing a new data set here. That's SAS help.class. So select star from the aforementioned SAS help.class. And now here's where we get into the data step options, or the data set options. Keep equals name, sex, and age. We can do a rename equals. So just trying to use a few of these options. This is the syntax you use for the rename equals. Age equals age renamed. And we could also use the where equals one that I've been using. It's not referenced there, but let's check out what happens. I should be able to try and use this in the renamed age column, which is called age renamed, where it's greater than 15. So students who are older than 15. And I think I'm good. SAS Studio always helps you close your parentheses properly, or your brackets, whatever you want to call them. So, like any sort of modern text editor is it's very useful in that way. So, so quit. Right. And see what happens here. So we have this one person, Philip, and this information on him, and his age is above 15. We may maybe get some more people in there. I think if we do greater than or equal to, yeah, that seems better. So we get a list of 5 people. So that's just one way. You know, you can use some of these different options here. Cool. So we'll move on to some other proc-sql invocation. I didn't actually give an example of this one. Obs will just limit you to the number of observations that you can take. You can just change that in here. Drop will specifically kind of does the opposite of what you're doing with keep. You'll drop specific columns. So I didn't give an example of those ones, but yeah, they're pretty straightforward, especially if you're coming from base SAS doing the doing the prior certification to the advanced programmer. This should be fairly familiar. So yeah, let's look at using proc-sql invocation options. So we're moving on to the proc-sql invocation options. And so I'll be doing proc-sql no print. We'll use the nobs equals option. So restricts, so we can read what SAS Studio says. This means it says restricts the number of rows observations that proc-sql retrieves from any single source. So we'll go ahead and use that procedure option, and we'll try it out with 5. We're reading again from the SAS help class dataset. So create table, call this one class 2, as select, I'm going to select all columns, so just use star, and then yeah, so I need the from statement, and so SAS help dot class, and that'll do it for us checking out the inobs. And so, as you'll expect, we'll essentially just read in those 5 rows, and then our output dataset, the work dataset called class 2, has 5 rows. So now let's look at we'll just go ahead and copy this and check out the outobs option. So outobs restricts the number of rows in the output. So here we're just gonna output 5 rows, and we could mix this one up by adding the order by clause. So say order by name descending. So we said we can clearly illustrate the difference between the inobs equals option and the outobs equals option. I also thrown the number option here. So this specifies that the select statement includes a column called row, which is the row number of the data as the rows are retrieved. Okay, so we'll take a look at, I didn't quite type that correctly. So let's go ahead and look at this. We'll call this by a different name, so it's class_3. Okay, so run that, and here we see the outputted data set. So if we took out the no print option, so if we took out the no print option, I'm expecting this in the results. So the number isn't actually in the data set, but it should be in the results. I'm not quite sure why it's not shown up in the results there. But anyway, essentially you see from what we're seeing here, specifies that the select statement includes a column called row, which is the row or observation number of data as the rows are retrieved. So it's not showing up in our results tab here in SAS Studio. So yeah, you wouldn't want to use it with the no print option, but it doesn't seem to be working. So not a big point, but that's what that option does. And I've been using the no print option all along, so we're pretty familiar with what that's done. So yeah, let's just look at some functions as well. We're going to look at the scan, substring, and length function. So we'll just make another SQL procedure here. Create table. We'll call this one baseball 5 using the SAS help baseball dataset. And so first off, we're going to use the scan function. And the scan function takes the nth word from a particular string. So in this case, we'll take the first word from the name column in this baseball dataset. We'll call that as last name using the as keyword. And then we'll use that scan function again, change the parameter to 2, and we'll call that first name. Now we'll look at using the substring function, which is similar functions in other languages. I'm also going to be using this cat function to illustrate it. So I'll use substring. I'll use scan inside the substring function with the name. So I'm taking the, again, so this is the first name. Could also use calculated first name here, but I'll just use scan again. So I'll scan name. 2 is the parameter, so I'm taking the second word in the string. And then with the substring function here, the arguments are 1. So I'm starting at the first character in the string. And then I'm finishing also with a string of length 1. So yeah, I think I have the right number of parentheses here. Scan. Substring. And so we're inside the cat function. And I'm going to take the substring. This time I'll take the substring. I'll just copy this. And I'll just take the substring of name I'll eliminate this scan function here, and I'll take the substring name, again starting at position 1, and length 1, and I'll call this initials. So this is the initials of a player, and I'll specify its length equals 2. And then I'm going to take a look at using the length function. So I'll say length name, or let's do just the last name. So let's again use the scan function. So length scan, name 1 as last name length, or something like that. Yeah, let's just do the camel case on this one. And then I'll just take everything else that's already existing in the data set we're reading in here with the star. So this is from SAS-help.baseball. Cool, and we'll just run this to check for any syntax errors, and take a look at what the data set looks like. Yeah, so you see here we've got the last names of each of the players, the first name, again that was using the scan function, and the scan function with the argument set to 1, so we got the first word of the string, and argument set to 2, so we got the second word of the string, and so on. And then here we use a cat function, which isn't listed in the functions, but I thought it was useful to illustrate the use of the substring functions, which we again took the first letter here from the last name and the first letter here from the first name, and developed these initials. And then of course we use the length function to get the length of the last name, and we can see from this player's name that that's the length of 9. And so yeah, there we've illustrated using the scan, substring, and length functions. Lastly, in the SQL section, we're going to move on to looking at using dictionary tables. So let's take a look at that. So again, we're going to do proc-sql. I use the no print option, and create table. We'll just call this one dict as select name from dictionary dot columns where live name equals SAS help, and mem name, so the table in SAS help equals ice job 4. Okay, cool. So yeah, so here's the member, and you'll see what the work library data set we create called dict looks like. Oh, yeah, I see the problem. This data set doesn't exist. So, yeah, let's use another one. Let's use cars. And we'll just take everything in there and we'll take a look at that. So, yeah, here we have the load name, the mem name, as in the dataset name. And here we, originally just selected name so we could look at the column names, but you can see here the some other characteristics that you can use for different things. You can reference the labels, the formats of each column, and so on. So basically, you get a row for each column in the data set, which can be useful for different things if you wanted to convert one of these into a list um, and get to see some applications of this perhaps when we go into the macro language portion um, coming up shortly. So yeah, I was just a bit confused because in the SAS On Demand for Academics version, I don't have the dataset I was going to use for this example, but we'll just use that cars one for now. Yeah, so that's about it for just the information you can get from the dictionary tables here. We looked at the members tables and different columns. So last example is something we've been using a lot, is the order by clause. Oh, sorry, no, it's the calculate keyword, sorry. So for the calculated keyword, we've been using that in a lot of different places. I think one of the first was when we looked at cars data set early on. I'm just going to repost that example underneath this. Or maybe we didn't. I'll just go ahead and copy that. And well, I can see we've used order by there, but I'll just go ahead and repost that under that heading. Sorry, we used the calculate keyword. So here we go again. And we'll just call this cars 12. So yeah, we're using the calculate keyword because if we didn't, we'd get this error because GB price isn't on the dataset we're reading in. So let's run that without the calculate keyword. And you can see we have an error. The following columns were not found in the table GP price, but if we add in the calculated keyword, we eliminate that error and we can do this query using that where clause. So cool. So I'll put that example there. And that's it for the proc-sql portion. So we're finished with the first of the three sections. Next we'll be moving on to macro processing. Okay, so to start with, we're going to be looking at creating a user and using user-defined and automatic macro variables within the SAS macro language. So simply, the simplest way to create a macro variable is to use the let statement. So let's say we'll make a macro variable here. In SAS, we don't need to quote a string, we can just write it like that. And then oftentimes one of the best and simplest ways to check that macro variable is resolving the way you want it to is to just use the put statement. So %put and then write out the macro variable to make sure it's working as intended. Or here we could also use the put statement to look at a system macro variable. So we can put date equals sysdate, or whatever we chose to do. So in the log now we should see these put statements, and we should see that name resolves to what I labeled name as in the let statement. So let's take a look at that in the log. Yeah, so you can see here, and and the date as well. Cool. So perfect. So yeah, let's move on to defining and using macro variables. Okay, so since we were in proc-sql recently, in the last section we could carry on in that vein here. So let's make another macro variable. Let's call it let car make equal Acura, and proc-sql no print create table cars underscore we'll call this car underscore 13 as select. We'll take every column from SAS help cars, and then we'll use the having option here that we discussed earlier, where we're going to take a subset and we'll use that macro variable. So we'll need to quote it because it's a string, and we'll just write car make. Yeah, so we made this macro variable here, and we're just saying having make equals car make, and this is sort of simple example in this one scenario, but just a basic example of defining and using a macro variable. Okay, so yeah, as we intended, we just got that subset of Acuras from the cars dataset. Okay, so let's move on to using a macro variable name delimiter and using the into clause in the select statement in SQL to create a single variable or list of variables. Okay. So with the macro variable delimiter, one way this might be easier is if I backed up a little bit. And let's say I created macro variable. Here I can always use this delimiter before I move on to something else. If I had a double name here, we wouldn't run into any confusion. It would resolve so. And it also becomes more useful in several examples we're going to use further on. So so we showed a basic example here, but we'll keep on using the macro variable name delimiter, which is a period, as we go through the this macro language section. So let's look at using the into clause, which is super useful. And so again, we're using proc-sql, no print, and I'll use select. So we're not creating a table because we're going to create macro variables with the into clause. So let's select make model and MSRP and into. So there's into stores the value of one or more columns for use later in another proc-sql query or SAS statement. Or I would say stores them as a macro variable, which is what we're going to be saying here. And yeah, like I said, you can use them later down the line for various things. So most expensive make. You'll see where I'm going to go with this. I'll use the max function. So most expensive model and most expensive MSRP. I want to remove that comma on the last one. From our dataset sashelp.cars, we use the having statement option here, having MSRP equal max MSRP semicolon and quit. But again, I like to use the I like to use put here to look at how our macro variables resolve. So let's do that here. Okay, so we're taking these three columns with where they putting them into macro variables where the MSRP is the highest. And right here, we're just using these put statements to see how they resolve, and that print out nicely to the log. So let's take a look at that. So yeah, here we see most expensive make equals Porsche, most expensive model equals the 911 GT2 two-door, and the most expensive MSRP is 192,000. Okay, so up here it also asks us to create a single variable or a list of variables. So let's take a look at how we might create a list of variables. I'm just going to copy this as the basis. So copy all of this as the basis. And I'm just going to take the make column for this list I'm going to make. And I'm going to say make into, just going to call this make list. And important now, I have to use separated by. And here I'm going to specify a delimiter. It could be a comma or space. You know, I don't know, whatever character you want. I think comma is best. it was what I would associate with a list in other languages like Python. So yeah, I would go with that, or if you think about a CSV file, that's how it would be separated. So I just go comma space, and then we'll see what that looks like in the log here in a moment. So yeah, actually this would result in a lot of different columns. We're just going to want to make this distinct, so we're only going to get one occurrence, so we'll eliminate duplicates. So we'll only have one accurate, we'll only have one Porsche, and so on. So very important to have that distinct keyword in there. Okay, so let's run that. And now you can see we got this list that looks like so: Acura, Audi, BMW, Buick, so on through Volkswagen and Volvo. And so that looks good as intended. So just to recap what we just did here, we used the into clause of the select statement in SQL to create a single variable, which is what we did. We made 3 single variables here, and then we also used it to make a list of variables, which is what we did here. Okay, so let's move on to using the simputx routine in a data step to create a single variable. Or again, we could do this to make a list of variables. I'll just give an example where we make a single variable for now. So we're going to use data null. So again, so it's the great thing about SAS Studio. It can explain if you're, chances are you're familiar with data null if you're watching this video, but data null specifies that SAS does not create a data set when it executes the data step. So it's like using the data step without actually creating a data set. So data null set. We're going to use the SAS help class. Where equals dataset option, sex equals m, and we'll do call simputx. So what does simputx do? It assigns a value to a macro variable and removes both leading and trailing blanks. So simputx name, and the second argument to the function is going to be age. Run. So how will this resolve? So let's look at the SAS help class dataset. So class. Okay, so we see Alfred here. So we're using name as the first argument and then age as the second argument. So for instance, if we put in Barbara as the name of the macro variable, it will resolve to 13, and Janet to 15, and Alfred to 14. So we can test this out with using the percent put statement. So we'll type out some strings, say Alfred's age is Alfred. And, see how that resolves. So yeah, this is exactly what we wanted. So Alfred's age is, and it resolves to 14, which is what we saw in that data set. And, we could interchange that with, I think there is a Henry in there. And so Henry's age is 14. So you should be able to do that with all 10 observations, and it will resolve that way. So that's how simplex, is very useful. Okay, so let's move on to taking a look at controlling variable scope with the global or local statement. So local or global indicate the scope of a particular macro variable. You could create global macros within a macro. For instance, the default for macro variables created within a macro is local to that macro. However, you can explicitly state that you want that macro variable to be global using the global statement. So that's what this is getting at, and that of course makes it available outside um, of that macro. Okay. So cool. Let's take a look at what this might mean in action. And so for the first time, I'll start using, I'll start a macro and I'll call it demo 1. Um, um, so if I said something was local, let's make a yeah, we'll use a let statement to make a macro variable. Generally, I'd indent a few spaces here. Again, if you want to, you can always format the code with this button here in SAS Studio. I'll probably leave a space here as well. So let's do %let x equal sysfunc. So I'm using the sysfunc keyword here, and again, you can see what that means. Sysfunc is used to execute SAS functions or user written functions. So I'm going to use sysfunc, and then I'm using the rand function. So I'm just getting a random integer, and you can look this function. It's just a function I'm using. It's not really related to the certification. So we'll do a percent put. I don't need to put that a line below. I'll just do percent put x equals ampersand x, and now do the main statement to finish our macro. So something I do, for what I think is a good practice, is to put the name of the macro here, and it's not necessary here. This works fine, but I think a good practice is to just put that there so you don't lose track of what your main statement's referring to. And of course, to run this macro, we'll do that. And so I'm not running the macro here, but if I want to run it, I'll just execute this one line. And yeah, so I get x equals 10. Cool. So I specify local here. Now if I'm outside of running that, if I'm outside of that macro, since it has local scope, let's see what happens here. And see, it says apparent symbolic reference to x is not resolved because I'm outside of this macro right here. But if I change this to global, or where it is by default, and I'm sure you can think of scenarios in your head where you do or don't want this to be global, or you want this to be local, i.e. only executed within the macro. So now let me change this. Again, when I'm just executing the macro, I'll get the same result. Right, I get x equals whatever it equals. But whereas before it said it didn't recognize what it didn't resolve to anything. Now I've used percent global statement, we get the same answer. So it's a global macro variable. Its scope is anywhere in this runtime. Okay, so I think that should be a good example. I'll just comment out this being local as I save this version. So cool. Let's press on. And yeah, and we can talk about the symputx scope parameter. So earlier we looked at the symputx function, and so you can add in a parameter here. I'm just going to copy and paste what we did earlier. And yeah, I'll just copy and paste what we did earlier. So yeah, this scope parameter will essentially be added on here, and G denotes global. And so yeah, that's about it. That's all you need to know about the symputx scope parameter. It's the same as what we discussed up here. It's global by default, but I just want to show you what it is versus the earlier example using symputx. And so again, it's gonna show us resolve Henry to 14, which was the age in the SAS help class dataset. Just something I think that's worth pointing out at this point is that there are these useful put statements that you can use in determining the scope of a macro variable. I'm just going to put them in here so you can do this. Use a specific macro variable, but the two I really want to show, because that's kind of this topic, is the local and the global. So if you're unsure about the scope of something, you put this in and we'll get a lot, because we're in SAS Studio. There'll be a lot of global macro variables. So there's most of them don't have much to do with us, but you'll notice some ones I've made. X resolves to 3, Thomas resolves to 11, Philip resolves to 16. These are all from the SAS help. My name is there, that list I made earlier is there, and so that's pretty useful. And you could also do the same for local, and yeah, nothing right now. So but if you ran it inside this and we had the local statement specified, that would return something too. So just a useful thing to have. I'm going to comment this out, but it's there if you want to use it. Okay, so now let's get to sort of a bigger part where I'm really going to try and knock off a lot of these bullet points in one go by discussing the next section, automate programs. Automating programs by defining and calling macros using the SAS macro language. So we're going to try and discuss all these bullet points with a large chunk of code. So define a macro using the percent macro and percent men statements. We've already kind of looked at that a little bit. I touched on that up here. So if this is your first time seeing something like that, well, you've already got an introductory example there. And then calling a macro with and without parameters. So we'll talk about what macro parameters are, just from what we just did in demo with macro demo 1. There were no parameters. Parameters would be added here, just like with other functions we talk about. So that was an example without parameters. We'll carry on down below and look at one with parameters. Document macro functionality with comments. Well, I think that's fairly straightforward. We'll try and give some comments on what we're doing as we go along. I also think, especially for when we put in parameters to a macro, we really want to talk about what we're doing and what those parameters are, because someone who's reading our code might not understand what the parameters are referencing, and we'll kind of look at what that is, what the importance of that is, and it's just generally I think what it's getting at here is giving some good comments here so that people can follow what you're doing. Generating SAS code conditionally by using if then else macro statements or iterative do statements. Yeah, so we'll definitely do this. We'll just look at meeting some conditions and then executing a part of the macro or not executing a part of the macro depending on whether those conditions are met. Using the auto call facility to permanently store and call macros. Yeah, we're not really going to do that, but I will discuss exactly what that means. And we'll look at using the scan, substring, and upcase functions, and some macro quoting functions in nr, str, and the string function str. Cool, and I think that'll do for this section. We'll look at some of the other parts further down, but that'll kind of be a good starting point for now. And we'll again touch on some of these in further examples. So let's start here. And so this is going to be a fairly lengthy example. So I'm going to start here with percent macro, and I'm going to call this SAS help DSN for dataset name. And I'm going to, so right here now, I'm going to make a macro with parameters. And my first parameter is going to be DSN equals, and I'm going to use percent string So mass, special character, and mnemonic operators in constant text at macro compilation. Okay. So it's generally a good practice to use the %str. And so this is going to be my first argument. And here I'm going to put in a comment. I'm going to say this is the data set name. So again, this kind of data set name. So this kind of goes to documenting the macro functionality with comments. So I'll try and do this throughout. And I'll just, and oops. Yeah, so if I just want to do an inline comment, I have to do the same thing there. So cool. So that was my first argument, and the first parameter. So that, again, these are separated by that comment. Sorry, by the comma, and then about is going to be my second parameter, and again, I'm gonna put another comment in. This is going to be description of the data set. Okay, so cool. And that's closed off. I'll need a semicolon there. And then I might just put in a line up here. Let's just say something about what this macro does for someone who's looking at it for the first time. So reads in SAS help library data sets. Okay. Cool. And now let's look at generating SAS code that conditionally by using if then else macro statements or iterative do statements. So this bullet point up here. So %if, and then I'm going to put my logic inside parentheses here. So and I'm going to use the upcase function. %upcase ampersand DSN. So that's my first parameter there. If that equals cars for the cars data set, or my other one's going to be PRD sale. So then do. And I'm going to indent free spaces while I'm inside the if then do macro statement. And I'm going to create a macro variable called financial. And it's going to resolve to this string if it's one of these two data sets. So this string is going to say this data set concerns financial data. And then I'm going to give an example of using the nrstr quoting function. So %put nrstr %upcase ampersand DSN. So NRSTR will not resolve a macro variable. That's sort of the purpose of why you want to use it. So you can use it in this case. I'll be using it with this put statement to say that this DSN resolves to whatever it is here, it will resolve inside this upcase function. So DSN dot semicolon. Cool. And now we'll close this, and I'll do that. So our indentation is consistent. Doesn't matter for the program running, but it makes it easy for someone else to read. So, and now we'll do percent else do also. So we talked about if then else. So we'll do else do. And we'll just actually copy and paste this. So we'll just make this blank. So we'll just say let financial equals blank. Yep. So it's very important to put a percent there. Okay. And now we're going to do a data step. So data, making a work library data set of the same name. So set SAS help dot ampersand DSN. And a run statement. We'll put a title in here, say about. And we'll put in title too, where we'll resolve the financial macro variable. And then we'll just do proc print. Also, I'll put in a comment about what I'm doing here. So I'm printing out the first 5 observations from the selected data set. Okay. And so I'll just do that using proc print data equals ampersand DSN, and I'm gonna use the no obs option. Actually, I could just leave the obs in there and just then say obs equals 5. Run. I know. Good practice is to just clear out these titles so they're blank. And now I'll do the men statement. Again, it's not mandatory, but I think best practice is to just put the name of the macro here. So you can easily keep track of where it begins and ends if you have multiple macros in a program. So now we want to put some values in for the parameters. When we actually run this, so we'll be using this SAS help DSM macro. And so we're going to put something in here. So let's start with cars. And about is an inventory of a car dealership lot. Okay. And then we'll pick a couple more SAS help library datasets for our macro. One is Iris. It's a famous data set. We'll call it Fisher's famous. Actually, it might be best off leaving that apostrophe out. Fisher's famous data set, which contains four or five? I think it's four classes of 50 instances. Where 4 classes of 50 instances where each class refers to a type of iris plant. Cool, I think that'll do enough for a description. And let's do one more. Actually, it's probably good. We'll just do those two. And yeah, so let's see what happens when we run these two. So we'll just run we'll put the whole macro in, and then we'll just run the first one, and then we'll run the one on the iris dataset too. So no errors, that's great. And we had some results. Yeah, so we got I spelled inventory wrong. Inventory of car dealership lot. This data set concerns financial data. So we got that financial macro variable to resolve to put out that string. And yeah, so we just printed the first 5 observations of that particular data set. And now let's just run the second one where we just run the with the parameter set to DSN equals iris and the spiel we wrote here about Fisher's dataset. Cool, yeah, so the second line's blank, which is what we intended, but we have this title that tells us some things, so cool. Yeah, so that worked as we wanted it to. So just to recap, we define a macro using the macro and men statements. We've earlier called a macro without parameters, and then this one we called one with these 2 parameters, DSN and about. We documented macro functionality with the comments we put throughout. We generated SAS code conditionally by using the if then else macro statements and do statements. So you saw that here where we set this financial macro variable based on what the DSN resolved to. And in the case where it resolved to cars, this string showed up in our output. And when it resolved to iris, we went down to the else do where this financial macro variable was blank as intended. We used some macro functions. I don't think we used scan or substring, but we used upcase, and you saw the use of scan in a data set earlier, so it'd be a similar thing, but here, but we can use it in open code, not just in a data set. And we definitely used the nrstr and str functions. And let's see if we can look at what happened in the log there. So put rstr. Oh, okay. So yes, this is what we were looking for. We were looking for some kind of feedback in the log. You see the nrstr. It said upcase DSN, which is what we wanted, didn't resolve that macro. But then where we're not using nrstr, it resolves upcase DSN. Looks like iris instead, which is what we wanted to illustrate there, that the nrstr function and some other quoting functions, but this one in particular doesn't resolve. Make sure that you don't resolve a macro, which can be useful sometimes if you're trying to put something in the log which has some meaning, like where we use this put statement here. So cool. I can now also look. I'm gonna, although we covered all these, I'm gonna put them down here again. In fact, I'm just going to take this one, although it takes this out of order. The look at the auto call facility, just to give you some code that illustrates how you might use that. So it's a little bit tricky because you can't really run this, but you might assign a or a macro library, and you'll specify that it's in some place, so somewhere, and then you use options mstored SAS mstore equals maclib, so the lib name we just made up here, m auto source, which causes the macro processor to search for the autocall libraries for a member with the requested name when a macro name is not found in the work library. Just from reading that in SAS Studio. And then if you're inside a macro, you could reference, sorry, my stored macro. So you could write a macro and store it in this location for future use. So essentially it's compiled, and so you can use a compiled macro at some future date. this macro, for instance, could be this simple. It's just a put statement saying calling my stored macro, and then end it with a main statement as before. And yeah, so if you wanted to reference this again, so if you ran this, it's not going to work because this location doesn't exist. It's not really something you can do in SAS on demand for academics, but I didn't want to leave it unmentioned. And it's not something you'll likely be doing in a certification exam. I certainly didn't see it when I took it, but it's good to know how to compile a macro in some stored location, and then you can reference it at some future point to call that macro. So yeah, I'm going to leave put this note in here so it's there. And I'll just put the order back so so it's in the same order as it was before. But I'll comment this part with notes on auto call facility. Okay, I'll just comment this whole section out because you can't really run it, and I want to make everything in here runnable, but I also don't want to not address this bullet point. So with all that being said, let's move on to the next sort of section. So we're going to be looking at using sysfunc, which we sort of touched on, to execute a data step function within the SAS macro language. We'll look at debugging, and then we'll look at debugging macros. Trace, well, this is kind of the debugging macros section. We'll look at tracing the flow and execution of with the mlogic option, the mprint object option, the symbol gen option, and use the put statement, which we've been doing a bunch of already, to print information to the log. That's kind of one of those bullet points that we've just been doing from the start in this section. So I'm going to give another example where I basically look at all these options that are used for debugging. Yeah, and we'll also look at using sysfunc for sure. So again, it's going to be another decently lengthy example here. So, okay, let's get started. Options. So this is where you set those kind of options, the mprint. So let's look at what they say for mprint displays SAS statements that are generated by macro execution. This is useful for debugging macros, right? So mlogic causes the macro processor to trace its execution and write the trace information to the SAS log, another optional useful debugging tool. And then, so these two I always go with, when I'm in my options, but symbol gen is almost gives you too much information, what can be really useful when you're first troubleshooting some code, but it prints a lot of stuff to the log. So SAS Studio says it displays the results of resolving macro variable reference. This option is useful for debugging. So every single macro variable you have, it's printing it out to the little log. It can be overkill sometimes. But yeah, useful to know what it does, and we'll look at what it does in this example. So macro systems options demo is what I'll call this. And so this is a macro with no parameters. So we just looked at one with parameters, and now this one doesn't have any parameters. Okay, so proc-sql no print. I'm gonna create a table called month years. So I'm going to create a table month, years, year. We can specify the format here with num4 month, I'll specify as num2, so 1 through 12, and I'll format that as Z2, so that means it'll have a leading 0 for the 1 through 9, and then I'll make a column called row num, should be num4. Just, an example I'm making up, semicolon, and I'm gonna use a %let statement here too. I'm gonna say let I, oh, that's 1, let I equal 0. Okay, and then I'm going to do %do g equals 2000 %2, we're going to use the %eval function here to then use sysfunc like we talked about up at this bullet point. So sysfunc executes SAS functions to user-run functions or user-run functions. So we're going to do sysfunc year. This is a SAS function from &sysdate, which is a built-in macro variable that we referenced earlier. So going to get the year from today's date, essentially. And yeah, so do g equals 2000, so the year 2000 to this current year. So that's 1 %do, and then we'll do another one, do h equals 1 %to 12 for 12 months. And then as I go through this loop, I'm going to add to this macro variable I made up here called I, and I'm going to say, and this is inside of these 2% do's, I'm going to say let I equal another %eval and %I plus 1. So I'm going to add 1. And all this is going to using an insert into. So I'm changing this table I started up here. So insert into months, years, values. So again, I'm using some options in proc-sql. We didn't say in the proc-sql section, but so you don't necessarily need to use what I'm doing here, but it's useful in this example for these macro variables and inside this macro. And so now I'm going to go back to this level and use a %end, and then back one more. So I'm closing all these do loops. Okay, so now I'm going to create some macro variables in a way we talked about earlier. So I'm going to take row num year and row num minus 48. And I'm going to use the into statement option to create a macro variable called max row num. Create one called max year. And then I'm going to create another one called start row num, which was back 48 rows from this one. Well, we'll see that as we progress through here. Sorry, I didn't need that indentation. From months, years, this data set we just made. And having row num equal max row num. Okay. So bear with me on this example, which is quite extensive. Here we'll add select put. We're going to use the MDY function, which is a bit of an obscure function, but it gets the month, day, year. It takes the month, day, year as its arguments. So I'm going to use month 1 for the day because the day doesn't matter in this example. And I'm going to give it a date format in SAS of mon YY7. And I'm going to put this as month, year, list, separated by, again, this we saw this earlier. So we're creating a list here using the into statement option here. And yeah, instead of using having for this one, I'll use where equal equals dataset option, where equals row num greater than or equal to percent eval I have too many parentheses there. Percent eval ampersand max row num. This macro variable will make up here minus 48. Okay. Finally, after all that, we'll do a quit statement. And yeah, sorry, this is quite an extensive example, so we're going to do some more here. So let k equals 0, but it really will illustrate all these options we set up top. So percent do j equals percent eval start row num, this macro variable we made here. So we all these macro variables are string by default, so using the percent eval ensures that they're execute as a number here. So percent %2 and then percent eval and row num. Oh, sorry, what do we call it? Max row num. My bad. Max row num. Then we'll change k as we go. So let k equal, just like we did with I in the previous loop, ampersand k plus 1 and proc-sql no print. Select month, year into month, ampersand j. And it's a good point to use the macro delimiter here. And year, ampersand j. From months, oh, spelled that wrong, months, years, where row num equals percent eval ampersand j. Okay. Okay, cool. Yeah, and we'll put a couple of put statements here too. To talk about using indirect references to macro variables, which will also be covered again a little bit later on, but useful to see how we can how we're using that here. So month ampersand j resolves to, I'm also going to use the CMPress function here. And this is where we use this double ampersand for an indirect reference month underscore ampersand J dot. And just the CMPress function eliminates any white space that we might run into here. And yeah, we want to see what month year list resolves to too. So let's put that there. So we use a put statement and say month year list. Sure, I probably made a typo, but we'll figure that out when we actually run this. Resolves to percent upcase percent scan. So we're going to use the scan function here. And we're going to use the super Q function, which is a super quote. Ampersand month year list. Sorry, I need to put that like that. Then as we loop through, we'll get the item from the list. So we'll put ampersand K. Remember this macro variable here. And then we'll add another argument, final argument for the separate comma that's in the list. So the scan function is not just looking from word to word and then gives the comma as an observation, or an item in the list would be a better way of describing it. Okay, so semicolon, and yep. So let's match that percent do with a percent end. And that's about all I wanted to do here. And we'll do a percent mend. We'll call this, and then, sorry, yeah, you don't actually need to put this, but we called it system options demo. And then to run it, assuming I got the name correct with no typo, I called it systems options demo. Okay. I think system options demo makes more sense. So, okay, we'll go. Just make sure our name's consistent. And so here, we'll do that. Okay, and it should run. I mean, there was a lot in there. Talking about 55 lines, so there may be a typo, but we'll figure that out. And you remember, the main thing is here we're looking at these options, the imprint, the M logic, and the symbol gen. So let's run this and see what happens. We definitely had some errors. So it's quite early on. Proc-sql. So create table months, years, argument 1 to function year. References. So argument 1 to function year. Okay, so function year. let's just see what happens if I did this to 2023. Will that solve my issue? Nope. Looks like I got further, but I still have some other issues. Invalid symbolic variable name, December 2019. Jan 2020. So again, we can follow through all these loops and see um, and loop through. I just cut out this put statement. I think that will get rid of our error there. So I think something in the syntax there. So cause a problem. So this is our month-year data set that we started at the beginning. You just kind of go through the years through 2023. I was trying to use a couple of extra functions, and I won't troubleshoot the syntax now. I just hard-coded that to 2023 for now. And yeah, you can see in the log the use of month. Here we're using indirect macro indirect references to macro variables where we said month, whatever J resolves to. You see on the last one it resolves to 288, and this indirect reference actually produces 12. So from here we get the value 12. And you can also follow through with symbol gen and see what every macro variable resolves to. You can also see with mlogic some things like do loop beginning, index variable I, start value is 1, stop value is 2, and trying to see an example of mprint here. Yeah, so mprint says the macro name, which is system options demo, and what's going on here. But mprint's sort of useful for following if you have multiple macros, like if we had other ones besides system options demo, following where exactly something is happening. And again, mlogic's sort of telling you what's going on, and symbol gen is just printing out every single macro variable, and there's a lot. So yeah, so you can follow all that in the log there, but I think that's a pretty extensive example. Again, I abbreviated it a little bit because I was having trouble fixing this. And the version I put on GitHub, which will be in the description below, I'll fix the syntax here, but I just won't troubleshoot it for now because it really wasn't that important. So yeah, let's look now at the next section, So I think we covered everything there, or the final section of the macro language section, which is creating data-driven programs using the SAS macro language. Again, we're going to use dictionary tables, and we already talked about indirect references, but we'll cover all these little bullet points as we go through this next macro. So yeah. So yeah, we're going to be looking at main key here is we're going to be looking at creating a bunch of dictionary references. I'm sorry, indirect references to macro variables with the double ampersand as an example. And so we're just doing proc-sql no print, and we're going to make use of these dictionary. For instance, we in this example we're going to use the columns to get the different columns that are in a particular data set. So so we're going to select the name. So that'll be the column name. We're going to put this into a macro variable called col name. And then, if we were in the first loop, since we're doing a fixed number, we could make this more data driven. If we wanted to get the number of columns variables in a particular data set, I didn't go that far with this example, but you could. So I just did it to a fixed number. And here, we'll be saving this macro variable as col name 1 through 20 as it loops through. Yeah, so and so we're reading from dictionary dot columns, and here we're going to do the where clause with where lib name is SAS help, like we've been using all along, and mem name we'll do the baseball data set. And again, for varnum, which would be the column number, we're going to make use of the this macro variable here, which I, and we'll, I'm missing an equals. Varnum equals percent eval ampersand I, and then a quit statement too. Yeah, so this will resolve to 1 through 20 in the different loops, and we'll be getting the if column from this SAS help baseball data set. And the main key here is we're just giving an example of using a dictionary tables and a repetitive macro call, and again the indirect reference to macro variables, which I'll put in a put statement. I need to close it. Well, actually, let me do the put statement first. So percent put the ampersand, and we're going to want to resolve that to the if column is, I use the percent cm press. I use percent cm press for this just because if you get any white space or anything, I think it's a good practice just to put this in. I sometimes run into this issue with using into. So just a good practice. I think it will work. You just have a bit more white space at the front. Without it, it just looks nice and neat in your log, and you'll see what I mean once we run this. So col name. Want to make sure I get this correct. I'll just copy that to make sure. Yep. Oops. What did I do? Okay. Let's try that again. Oh dear. Call name underscore should do it. Okay, let me try and copy that. Okay. Cool. Yeah, and then I'm also going to want the %I. Okay. So yeah, this is what we want to look like at the end. We've got the double ampersand here, and the number right there. Okay, cool. And I want to close this do loop. So %end. Keep my indentation consistent, and now we want a mend statement too, so let's do some mend. And you don't need to, I've mentioned this a few times, but you could put the name of the macro in there. I think it helps in general, especially if you have macros inside macros or something of that nature. It's just very useful to keep track of that way. So dict example, and we should be all set to run this. And then we'll look at the log, because we're really just looking at this put statement to see, look at the indirect references, as well as just using the dictionary tables too. So let's take a look. So ran with no errors, cool. And so yeah, you see here, so our, look at the 20th. The 20th column is N assists is the, I think that's what this stands for from the baseball data set. 19th column is N outs. 18th column is position, division, 17th league, CRBB, CRBI, CR runs, okay, and so on and so on and so on as we go back through the loop. So again, how we could have made this more data driven was perhaps do the, there's a number of ways we could have found the number of variables in this SAS data set, and it could have been dynamic too, then we could have perhaps added a parameter for this guy, so we could have used any SAS help data set and returned the if column for that, but I didn't go that far with the example. So yeah, that's about it for this section of macros. Now we're going to be moving on to advanced techniques, which is kind of like a coverall for a bunch of different things, but it starts out, so this is the last section just to cover what we've been through so far. We've been through the SQL procedure and now through SAS macros. And now we're going to jump into advanced techniques, which is actually just arrays. And after that, we'll get into processing data using hash objects in SAS, which is quite a large section of this final sort of coverall section called advanced techniques. And then we'll finish off with a couple of other things, looking at brief look at proc format, the format procedure, sort of adding format to your outputs, and finally we'll also look at proc FCMP, where you sort of create your own custom functions with the FCMP procedure, and some more obscure advanced functions we'll see down here, and a very quick sort of look at regular expression pattern matching with the last sort of 3 or 4 bullet points. And so that's what we have left. So let's get started. On section 3, we'll be starting off with some examples, looking at the use of arrays in SAS. So we'll start off with I'll try and do this whole bullet point and sub bullet point in one. So there's not necessarily a good SAS help data set that I want to use for this example, so I'm just going to make up my own data using the data line statement. So here's my array statement. Again, the great thing about SAS Studio is you can sort of look at your options and information on what the you know, on what's involved in a data step statement, or any other sort of keywords you type in. So N5. Okay, so what I just did with the first array statement is, the array statement is used to declare an array and specify their dimensions. So this one I'm calling lowercase. Put some space. Lowercase. This lower underscore case array is declared with this guy to sort of denote that it's going to be a character in front of the variable names. That's going to be a character array, and it's going to be the variable names are going to be n1 through n5. So yeah, there we go. So I'm going to do one array there, and then I'll do another array statement. So we'll call this one uppercase. Right, upper, if I can spell that correctly. Upper underscore case. And again, same deal. It's going to want to be it's going to be character. It's going to be a character array. 1 through C5. Okay, and now the input statement, because I'm going to bring in my own data. Lowercase. And so now I'll do a do loop. I'll do I equals 1. Oh. I equals 1 to 5. And so, sort of in summary, what we're doing here is we're doing this do loop to iterate over the elements of the two arrays. So uppercase, I equals upcase. So we're using the upcase function. I turn the so we're using the we're basically converting several lowercase names, as I haven't typed in the data lines yet, but we're going to convert all these elements of the array, as we would call them, in this other array called uppercase, using the upcase function on all the elements in the lowercase array. So let me just keep on typing. I semicolon. Okay, and we'll need to end that do loop. And now, of course, what I haven't done is to type in some data. So I'm just going to take like 5, because I've defined it as having 5 elements. So I'm just going to take data. I did that wrong. Data lines. Let's go Bob, Jeff, Tom, Frank, and Hank. Yeah, cool. That's 5. Cool. And a run statement. And okay. And we'll take a look at what this work library dataset array example _1 looks like. Cool. So yeah, you see we had the element, because we're saving it as a dataset. We have the original 5 elements from that lowercase data array called M1, N2, N3, N4, and 5. They're there. Then after that, we define that other array called uppercase, upper_case, and looped through all the elements of the lowercase array, and then we sort of converted them all to uppercase array elements, which we called C1 through 5. So there we go. Very basic example of using character array and referencing array within the do loop. And yeah, we also defined arrays as temporary arrays. We'll do another example too that sort of captures the other parts of this. So yeah, let's call this so we cover all these sort of bullet points with arrays. It's not a huge section, but you want to have some understanding of what's going on. So let's call this example 2. Again, I'm going to sort of make up my own data. I'm gonna use yeah. So imagine, if you will, that there are 2 cities with 2 different populations tracked over time, and I'm going to go through these sort of 10 variables, 5 population measures, which I'm going to call P1 through P5 from 2 cities, C1 and C2. And I'll do an outer do loop and an inner do loop to for this array. Okay, so it's the array statement, population, and my dimensions, and then it's going to be C1 P1 to C1 P5, and then of course, because I got the 2 cities, it's going to be C2 P1 through C2 P5. Okay, cool. And then I need an input statement. So input C1 P1 to C1 P5, and the same thing. I probably could have copied and pasted it so I don't get confused. And C2 P1 through C2 P5. Okay. All right. Yeah. So now here's the first do loop. Yeah, let's put a line space there. Do I equals 1 to 2, and then do j equals 1 to 5. Cool. So we're inside 2 do loops here. And inside the second one, we'll do calculation. So we got both our dimensions. We got our dimensions here, I and j. Oh, sorry, I typed 1. I and j. And then we're going to round, we're using the round function in SAS, and we're going to round our raw population data for some reason. Maybe we want to do that. And then we're going to end this do loop. And then we're going to end the other one. So cool. And now, because again, I have to type in the data, I'm going to type in some data here below. So actually I have these values on my clipboard, so to save you having to watch me type these random numbers I made up into SAS, let me just copy and paste. And so that should do it, and then the run statement. And yeah, sorry, I've typed in I instead of 1 here. So that's city 1, population 1 through city 1, population 5, and city 2, population 1 through city 2, population 5. I think I copied and pasted my mistake there. Anyway, so let's run this example and see if there's any errors in the log or anything like that. Otherwise, we'll move on with a discussion of what happened. There are errors in the log. Oh, sorry, do j minus 1. I think it should be do j equals 1 on the second loop, the inner loop. Yeah, that should fix that problem. Otherwise, it looks good. Okay, no, sorry, there must be something else wrong. So let's troubleshoot what's undeclared array referenced population. Oh, I spelled it, yeah. So, yes, I spelled it wrong in the beginning. So it took me a second to figure that out. I spelled population wrong up here, so then it tells me down here it's an undeclared array. Okay, so the trouble with yeah, sometimes it can be a little bit convoluted figuring out what the issue was, but I think we're there. Let's see if this runs without an error. Yes, it does. Cool, perfect. Goodness. All right, so all right, now let's get into a discussion of what we did here. So on the SAS data set, we created a two-dimensional array called population, and the populates it with data from this data line statement that was down the end. The array statement that we use is used to declare the array and then specify its dimensions right here. And so this is going to mean that we got 2 rows and 5 columns with the variable names C1, P1 through C1, P5 for the first row, and then C2, P1 and C2, P5 for the second row. And yeah, and of course the input statement we have to that we use has to be put in there because we're going to read the data with this data lines statement further down. And so yeah, so there's this nested do loops which iterate over the rows and the columns of the population array, and essentially we're just finding a way to do some sort of action on each of these, and that's use the round function to round these numbers, which are in decimals. Maybe you know, population, maybe we're thinking you know, some numbers are made up, but maybe it's in thousands, like that's 799,900 and something, and I've rounded it to 700 and, oh sorry, 800,000 I guess would be the result with the round function, and so on with this array. But you can see for a larger data set how this array could be quite efficient across multiple rows and columns. Is sort of the idea of why we're doing this. So just to summarize it, you know, this program, because of the nature, it defines a 2x5 array that's called population with these elements that we could run through C1, P1, C1, P2, C1, P3, and so on through C2, P5. And then reads n values from the data lines that we put down here. Typically in a lot of our examples we've done using the prepared SAS help library data sets, but there isn't a great example that I could think of to use for multi-dimensional array. So I made up my own data. So then reads in these data and assigns them to the elements of the array, and after that it loops through the array to use this just simple round function to do just a simple operation on each of the elements. So with that being said, we kind of covered all we need to cover here for this small array subsection. And that should just give you the intro you need. Maybe play around with this code a little bit on your own, just to sort of get a bit more familiar with processing data using arrays. Okay, so now we're going to move on to processing data using hash objects. And so first, I think we'll start off by trying to look at several of these first few bullet points here in one data step. So just before we get started with processing data with hash objects, I always like to think of it in sort of 3 steps. We declare the object, and we'll kind of get to what that is, the hash object, and then we define the hash key and data variables in step 2, and then in 3, sort of the third step, we complete the definitions and load the data into a hash object. And so we'll sort of, as we go through at least a few of these examples for these different bullet points, we'll sort of keep on talking about those 3 steps. So let's start out with data null. And I'll reference these bullet points up here as we go along to, especially when I've finished typing, and we'll talk about which ones we're sort of checking off as we go along. So I'm going to be using the good old SAS help.cars data set here. Oh, sorry. I put if we want if0, then set SAS helps.cars. So what? Just before we get started, why are we always sort of doing this? If 0, then set. It's kind of necessary to let the data. A good key for what we're going to do later on is to let the data step know the attributes we want for our variables that we're going to be reading from SAS help.cars, and there's no better way than to basically put an empty data set in there that contains the attributes, like the variable length, or any formats that may be there for these variables that we're going to use. So that's just sort of background as to why we're doing that. Okay. So and then if underscore n underscore equals 1, then do. And okay, so here I'm sort of doing the first step of declaring the object. So I'm declaring. So you can use declare. There's also like DCL. Either works, but I think the preferred modern term is declare. So we'll use the declare statement. Declare hash, and I'm gonna say hcars is the name of the hash object. And we'll sort of talk about, I'm going to use the ordered argument here. So I've declared the hash object. We're not declaring a hash iterator object on this one. But I'm declaring a hash object hcars. I'm saying it's ordered, and D means descending. And multi-data, I'm going to set to yes. So that's the ordered argument and the multi-data argument. Okay, so we're going to carry on by after we've declared the object and declared sort order and declared the multi-data argument set to yes. We're going to define the hash key and we're going to define the hash key and data variables. Okay, so we're going to do that with the define key method to start with. So hcars dot define key, and we're going to make it make model and MSRP. Okay. And then we're going to do the define data method. So we're just defining the hash key and data variables here. So define data. And we'll take these same three and then we'll look at the origin and type 2. So let's put an origin. We can just put them in this order: origin, then type, and then these three. And then hcars dot define done. Just to say we've completed the hash table definition, basically. Okay. Oh, didn't mean to do that. And we'll end the if then do with an end statement. So cool. Now we'll also do a set SAS help dot cars and set end equals. It's a statement option that creates, like it says here, a temporary name that contains an end of file indicator. Sometimes you see it as EOF. I'm just going to call it end. Semicolon. Okay, and then we're going to use the add method to add the data with the key to hash objects. So hcars dot add, and then we're also going to use the output method and use the data set argument in the output method that's referenced up at the top. So let's do it with if end. So that's our end equals end. Then yeah, we could just indent this one. Hcars dot output. Sorry, this is and then we'll use data set, and this is where we're gonna save our final data set. We'll call it hash dot example. Oh, sorry, hash underscore example underscore 1. Cool. Semicolon, and then we're done. So we'll run this. We'll take a look at what our data set looks like. It's kind of a there was a lot there, but we weren't doing much. But we ran through some of the things you can do with hash objects. But the key here was we declared the objects. So these 3 steps I'm emphasizing. We declared the hash object. In this case, we define the hash key here, and then we define the data columns or data variables here. Sort of step 2, we define the key and the data, and then step 3, we completed the definition, and then we loaded the data here essentially. So we didn't do a whole lot of anything here in particular, but we just sort of discussed using these basic hash object methods. We didn't use the hash iterator object, but I'll have another example where we do that. Okay, so basically we took these particular columns. We also noticed we made it with the descending ordered argument by make model MSRP, and we sort of can see we start from the back with Volvo, the V being, I guess, the last, in the order of makes, Volvo is the last one, and then XC90 is the last one of the models. Yeah, and then we go on down through the makes to Volkswagen, and then we'll probably end up with Acura at the end. That's the first in the alphabet. So just emphasizing that we use the ordered argument. So yeah, let's move on to using some hash iterator object methods in another example. So we'll use find add. We did use the output method and the add method in the previous one, but we'll use some of these other ones in the next sort of example. So yeah, let's jump into another example. So we'll call this data hash, just trying to show a different way to doing it than the way I did it up here where we use data null. So I'll just make this hash example 2. We'll keep on using the cars data set. So set SAS help dot cars, and then we'll do this end equals statement option end equals end. Okay. And so here we'll do if underscore n underscore equals 1, then do probably a good idea also to set set the column attributes that we want. So I'll do if 0, then set SAS help dot cars. Keep yeah, we've done the keep equals dataception here, and we'll do just MSRP and horsepower. Okay. Okay, so now we're getting to sort of our steps where we're getting to these 3 steps again, where we're first declaring the object, and in this case we're gonna do we're gonna declare a hash object, and we're also gonna declare a hash iterator object. Okay, so first declare statement, we'll do declare hash, and we'll just call it, we can call it whatever we want really, but I'm just going to call it hcars like we did in the first example. Hcars dataset is SAS help dot cars. again, we're referencing SAS help.cars again. We up above we got the dataset attributes there, and we're going to declare the iterator object method. So declare iter, and we can call this. We'll just call this one hcars iter. Yeah, that works. And we're going to reference this guy up here, since the we declared the the hash object here. Now we're going to declare the hash iterator object, and so cool. There's that, and now we're going to move on to what I always think of as our second step here. We're going to define the hash key and the data variables. So hcars dot define key as our starting point, and this time we're just going to make it the make and the model. And then for defined data, we're going to do those two plus the MSRP and horsepower I kept up here. So we'll just do a bit of copying and pasting here just to save a bit of time. So make model. We could even copy and paste these, I guess. Okay, and semicolon. Cool. So define data and then hcars define done. So we're just saying we've completed our hash table definition there. Okay. Cool, but I'm also going to show in this example, some other things you can do. You can sort of have two data sets going on in the same. So I can make two two work library data set. I could make multiple, but I can output as you can in the data step. You can output another work library or some other library data set at the same time as you're writing one up here that we've already expressed in hash example 2. But I'm gonna do another one. Let me finish out the define data here, and I'm gonna do this by creating another hash object. I'm gonna call this one. So I'm gonna declare it just like I did before. I'm gonna call this one hash. Hcars sum. Okay. And I'm just going to make the key to this one make. So it's a little bit different. I'm just going to copy and paste this in the interest of time and adjust as I want to. So cool. I'm just going to take make, not model. And then I'm going to make my own column called total make. And then it's make. Yep, total make. And then total price. Total price. It's kind of like some grouping we're doing here. And just it's, sort of, I'm doing this for a good demonstration of what, you can do here. Sorry, I realize I made a mistake now. I used define data twice, and I want to make that define done. It should be the define done method there. So yeah, we don't want to have that in there. Okay, so perfect. All right. Okay, cool. And let's close the if then do. Okay. All right. So now we're gonna look at using some of the methods you can use with the hash iterator. Use the hash iterator object method. So you've got your hash iterator object and then the methods you apply to them. Okay, so let's start with if h cars, and we'll use the find method first. Dot find not equal 0, then do. Let's call this, I'm just going to make a variable match equals 0, and then I'm going to add to this in a do loop. Okay, so, and then I'm also going to use another, I'm going to make another column called RC, and I'm going to fetch the first line of the hash table here. So RC equals hcars iter, just want to make sure I don't spell that wrong. Hcars iter dot first. So the first method, oh, spell it right. That fetches you the first line of the hash table. Okay, now do while. So using the while keyword, which, as you see from here, executes a statement in a do loop repetitively while a certain condition is true. So while RC, make sure I get the syntax right here, RC equals 0, and then if model equals model, then do. So while you're in a particular model, match equals 1, and RC equals 1, and else, sorry, yep, sorry, I want it in that same loop. So we'll then move on to the next outcome if the if then do condition is not met. So hcars iter, again, let me just copy, make sure I have that on my clipboard. So hcars iter next. Okay, and then we'll end the original do while and go to if match not equal to 1, then do. Call missing, and we'll go through a good explanation of exactly all of what we're doing here. In sort of a summary, if I just want to make sure I spell all the variable names correctly. But if we run into an error, we'll troubleshoot it, and it's good if I do have a syntax error, then we can walk through troubleshooting it, because chances are that might happen. So I'm going to use delete keyword here that will, as it says, will stop processing, forces the end of the iteration and moves on to the next one. Cool. And now we're going to end, so end this if then do at the top. Oh, sorry, that should have been find, the find method. So there's a lot of chances for some syntax errors. I'm just randomly spotting them right now. Yep. So now, Now for the where the hcar sum hash object we made up here sort of comes into play. So let's get started on that. So if, we'll try and speed up a little bit here, hcar sum, I mean the case doesn't really matter here, but I just yeah, I wanted to use camel case for this, so it just looks a little bit, I just prefer the look of it. Not equal 0, then do. Okay, what did I call these guys? So total make. So I'm going to set these equal to 0. Total make equals 0. Then delete the stuff. Total price, I think. Yep, equals 0. Okay. End. And then outside of that, I'll add, total, let's get this right. Total make equals total make plus 1. And total price equals total price plus 1. All right. And then, yeah, we're going to use the replace method here too. So we're still in hcar sum. I'll just put a space in here. hcar sum dot replace. Cool. And an output statement. And yeah, if then, oh sorry, if end, remember this end keyword we used all the way at the top. If end, then hcars sum dot output, and yeah, so data set, we'll call this one hash example 3, I think we're on now. Okay, and run statement, and that's a pretty long data step, so I feel like there's probably a syntax error in there, but we'll take a look, see if there is or there isn't. Nope, we got errors. So, oh, okay, yeah, there's a problem. Looks like I have an extra comma in there. Yeah, that was hcar sum. Okay, so that's a problem. Okay, maybe that was the cause of the second error too. We'll just run this again. Take a look at the log. Oh, there's still an error. Okay. RC, use hcar editors. Oh, yep. I think I'm missing a semicolon right there. So let's fix that too. Okay. All right. See if that solves all our problems. We got results, but we still have errors. Okay, method define key must be called before define done. Method define key must be called before define done. At line 82. Oh, I think I referenced the wrong. Yeah, this should say hcar sum. Okay. So sometimes it's good to just see me like struggle through a bunch of stuff. Um, so you might run into similar issues. So my hash object here should be called hcar sum. And hopefully I didn't run into that further down. No, it looks like I'm good there. I did call hcar sum there. Okay, so let's see if after these 3 attempts, that's a third time lucky, or is it 4th time? I think it is a 4th time. Okay, now we're looking like we're in business here. So, yeah, let's sort of run through talking about, how exactly, let's walk through the data step that we just ran. So basically here we, in the hash example 3 work library data set, we have these columns where it has a total make, like think of it as an inventory of your car lot. If the SAS help cars was, that's what the data set was for. You have 19 Audis and a total, something's going wrong with the total price column here. That's not what we wanted the total price to look like. So where have we gone wrong here? And it's, yeah, I see now I got +1. So I'm just adding 1, which is what we want for counting the iterations of total make, but we want to add the MSRP to each instance there. Okay, cool. So this would make a lot more sense. Okay, so it's like the 5th time I've run this. Hopefully this example works now. Yeah, okay, so perfect. Yeah, this is what we're looking at. So then we'd be looking at, we got 19 Audis and a total price of $822,850. So, maybe you could take an inventory with the way this works. You also see example 2, has a lot of the original columns. It also has some junk that we put in it, and like a running of the total make and the total price. So it's kind of interesting that you get to see that the way I had 2 data sets outputting. Yeah, so let's just walk through this code because that's a really big data step. So let's sort of walk through it. So we had the first hash table here that we declare with this hash statement. And we specified SAS help.cars, as the input. We also made sure we got the characteristics of MSRP and horsepower up there in terms of the the format of the data. The second hash table, we made we also declared the the iterable table, but we declare the sum table here. But we only use the key for the just the make instead of the in the other one we had the make and the model. And we made up our two new data columns, total make and total price. And then so we sort of, then went on to perform some operations for each input in the data set. We would be looking for the key make and model in the hcars in the hcars hash table. And if the observation with that key is not found, we call missing for what do we do that? We call missing for MSRP and horsepower. And this is really where we use the iteration hash table for determining whether it's the first whether it's the first sorry, whether it's the first line of the hash table. That's a good way to say it. The first line of the hash table, or whether we'll move on to the next line of the hash table. So if it doesn't find the key, eventually, it moves on, and then it kind of leans into here how we are still, we iterate through to, again, using we use the find method to then do this sort of running total based on the make in the hcars sum data set. So again, if it doesn't find the key in the hcars sum hash table, it initializes total make and total price to 0, and then the increment total make and total price keep on going by adding 1 to total make and the MSRP to total price as you go through, and then you replace the value, and then we replace the value of hcars sum in the hash table and output the observation. And at the end of the data set, but this, when we get to the end, we output hcar. We output this data set called hash example 3, which sort of was the purpose of what we were doing, where we have this sort of total, like you're looking at your lot, and this is the number you have of each make and how much the total price is of your inventory, if that makes sense. So that's kind of what we were getting at, but we managed to work in all these bullet points here. We didn't actually use the last one, but if you understand when you're iterating through this, first method will give you the the sorry, the first method will fetch the first line of the hash table. The last one will fetch the last line of the hash table. So yeah, it's just it's a pretty extensive example, definitely the most extensive in this whole tutorial. But hopefully that gives you a feel for what you can do with hash tables, and sort of just runs through some of these examples. Okay, so let's move on to sort of the last example or two that we'll look at using hash tables for. Again, we'll try and we'll first look at them. Let's look at using using hash objects as lookup tables first. Okay, so data null. if underscore n underscore equals 0, then set SAS help. I'm using a new data set here from the SAS help library. It's called SAS help shoes. And I'm going to use the keep equals data step option. Key to keep product and sales. Cool. Yeah. And so, yeah, just to sort of talk about our three-step method again. With hash tables, we're going to declare the object, define the hash key and data variables, and then do stuff with the definitions. Cool. So again, we're going to declare hash. I'm going to call this h shoes. Just put some space down there. And so data set is SAS help dot shoes. We could, we can use some of the other we could use we use the dataset argument. We could also use the ordered argument and the multi-data argument too. Yeah, let's use the ordered argument. We could just make that ascending. How about that? And multi-data is going to be yes. So multi-data y. And let's not forget the semicolon. Cool. Alright, so and let's do hshoes dot define key. So we want to define the key. It's going to be product for this one. If I can spell that right. Product. And then hshoes dot define data. So we'll define our key, we'll define our data, and define data, and we'll make that'll be both the key and so product and sales. Okay, and then we're going to do define done. So we sort of complete our hash table definition at this point. So hshoes dot define done. So in step one, we declared our hash object, and then we defined our key and data in the second step, and now we're going to do some stuff. And the purpose of this data step, this null data step, is to use a hash object as a lookup table. So we're going to look for a duplicate product, which is a slipper. So if there's more than one slipper in the SAS help.shoes data set, we'll be looking for that. So this is how we go about doing that. There is more than one slipper, so it's fairly straightforward to see that if you go look at the data set itself. But we want to programmatically do that as a, using this opportunity to use a hash table as a lookup table for using the hash objects as a lookup table. Put RC. So I'm just going to put this RC equals product equals and sales equals. So here we can really see, that it is a duplicate of the sales. The number is different just from my knowledge of this data set here. And this will spit out to our log if there are multiples of the, of this product of our key. Okay. And we'll just make another variable called another product, and we'll just set that equal to missing value. And so, yeah, even if we so now we're going to use the has next method, which determines whether there is a next item in the keys data item list. So let's do RC equals shoes is our hash object. So hash object dot has next. And our result, or our is another product that we declared here. Yep. So now we're going to want to do while another product not equal to 0. We're going to do RC equals shoes dot find next. So this is the spell it right. Find next, and then we're going to do the put statement to the log. And we'll just add on I'll just copy this and then I'll add on another product as well. And another product equals. Okay. Alright. So, and then RC equals shoes dot has next. And we'll set R, or result, equal to another product again. And I'll run through this after we make sure it runs properly. We'll end the do loop. And we'll just put in a stop statement as well to make sure we stop executing the data step. Since we're doing nothing else. Okay, so we'll do run statement, so it runs. Okay, cool. So we'll go ahead and run this, and then we'll sort of look at what we're expecting with the put statements. In the log, we're not really writing a data set here, so. The variable prod cut. Okay, I spelled product wrong. So just troubleshooting this first. The variable prod cut. It's never been referenced, so just fix that typo. And let's see if we have any other errors. Okay, we do. Oh, I think I put accidental period there. So we'll delete that and try running again. Okay, cool. Yeah, so we see here, we write to the log. You know, if we never get to another product, then we'll just have this, but because there's duplicate versions of the slipper, we get this information, and we can see they're duplicate because the sales numbers are quite different as well. In addition to this, another product variable we made. So just to sort of summarize what we did here, where we're looking using hash objects as a lookup table. Just to sort of recap, we declared hash table 8 shoes using the input data SAS help.shoes. The hash table was ordered. It was multi-data, and there were multiple data columns or variables, which were product and sales. Then we set the value of variable product to slipper, so right here, and looked for the corresponding key in the hash table using the .find method. And this method, sort of, we set it so that this method returned 1 if it finds another record with that same key, and is 0 otherwise. If that duplicate record is found, then it will call that hshoes.find next method to find the next duplicate record, which in turn is then printed to the log, which is sort of what we end up seeing a lot of after this first instance, because it's a big data set and there's multiple duplicate records of slipper. Yeah, so just basically in summary, I guess this program is only looking for duplicate records of the product slipper and just printing the records, but we're not doing any sort of data manipulation in this data set, but we're just kind of satisfying this objective of using hash objects as lookup tables. Okay, so we'll just look at a couple more things involving hash objects, namely using hash objects to create sorted data sets, which we've kind of done already. We'll just go over that a little bit more, and yeah, and we'll talk about you know, the difference that'll make in terms of using them to access, you know, we can use iterator objects to access data in forward or reverse order. I'm actually going to head back up to the first example we used with hash tables, and just yeah, we'll just go ahead and copy that. And just sort of point out the difference you can look at here. So we're just looking at creating sorted data sets with using hash objects to create sorted data sets. We'll call this example 4, hash example 4. Okay, so if you set this to ordered D as we did in that earlier example, your sort of outputted data set of example 4, descends from Volvo, and the model is XC, so on and down through in alphabetical order in terms of the model too. But then if we wanted to change the way it's ordered, and then in turn the way the different methods are executed, we set that to A. So now if we set that to A, we're on accurate and again down through the alphabetical order in ascending order. So I'll just leave that example in place, even though I just copied it from the first example, and that'll be it for talking about hash tables. And we'll move on to using SAS utility procedures. Specifically, we're going to look at using proc format. Specifying a template using the picture statement within the format procedure. So proc format. Picture. And I'm going to call it $pic. And I'm going to give it a prefix. And so you could do a fill option here. So I'm just going to leave the fill equals option as a blank space, but you could add something in there if you wanted some character. And then we're just going to do the print procedure. Proc print data equals SAS help dot cars. Limit it to 10 observations using the obs equals dataset option. Also use the no observations so we don't have the index or numbering on the left. So here's the format statement. MSRP is the column that I'm going to format with this $pic format. Don't forget to put a period on the end, semicolon. Then I'm just selecting with the var statement, the columns I want, make model, and MSRP, and then run statement. And then we'll take a look at what the print procedure outputs. Cool, yeah, so you can see we have our customized format. The bullet also mentions several other statement options. So there's the round option, which rounds a value to the nearest integer. There's the data type 1, which is worth noting, but it enables the use of directives in the picture, mainly used for sort of formatting dates or times or date time values. Yeah, so that's about it for the example with the proc format with the format procedure. So yeah, let's move on to looking at the FCMP procedure. So we'll create a user-defined function using the FCMP procedure here. Let me write it to an outlib, which we can use to demonstrate using custom functions with the global option cmplib, as we set the option below. So we'll call this, it'll be in work library, so work.funcs.trial, and we're going to call the function price with tax func. And so we'll run through after I've typed in everything, what exactly is happening here, and then also we're going to implement it in proc FCM, using proc FCMP as well, and another, after we've run it, we'll also use it in proc FCMP. Okay, so if tax rate equals missing, then tax rate wrong. Then tax rate equals, we're going to set 7.25%. We could set this with some sort of macro variable as well if you wanted, but we'll just do it like this. Text price then equals price multiplied by 1 plus tax rate. And then we'll return the tax price. So return text text price and end sub. And a run statement. Okay, and then what I was talking about with the making the global option cmplib and setting it equal to where we stored it here, so work.funcs. And yeah. Okay, now so to implement it in the proc FCMP, so we're going to be using data equals SAS help dot cars as our input, and our out data set is going to be we'll call it car price with tax. Format. Yeah, then we can add a format, and we'll call this column MSRP with tax, and we'll make it $8. Okay, and now for the calculation, just make sure I get the name consistent. So MSRP with tax equals, and so we're going to use, copy the name of the function we made here, except this isn't going to be price, it'll be MSRP, yeah, so we'll use that. And then run, and so we should then get this outputted data set with car price with tax, and then we'll just run through what we did because there was a lot going on there. I think there's actually a typo right here. It jumped out at me. And yeah, so let's take a look at the outputted data set, which will be car price with tax. So this is the data set. So we should have a column or variable here, MSRP with tax, that was made using our function. And yeah, so here's, here it is formatted the way we wanted, and presumably it's, it looks like it's calculated the way we want it. So yeah, basically 1.075 times this guy. So yeah. So let's just run through all that we did in that. So in the first procedure, we, using proc-fcmp outlib equals work.funcs.trial, we create a user-defined function that we called price with tax func. Basically calculated the price of an item with tax added. It could be generically applied to lots of different data sets. When the function is called, actually it does a check as well to see if a tax rate has already been defined, and if not, then it assigns this tax rate of 7.25%, and then it calculates the tax price by multiplying the input by 1 plus the tax rate and returns the result. So then in the second procedure, we sort of use this user-defined function that we made in the first procedure and apply it to the SAS help.cars dataset with the tax added, and we also use that format statement in there to get that particular format. It's used this price, which I didn't intentionally spell that way, but I think it would make more sense if it was spelled like this. But I copied it, so that error came down here too. Yeah, we used that to calculate the value of the new variable, which was called MSRP with tax. So, but you can see how, it's worth noticing that with the outlib option of proc-fcmp, we create a permanent, although I stored it in the work library, we create a permanent stored function in the library using that option comp lib that can be the idea with that is that you can use that price with tax function, if you reference the comp lib with the FCMP procedure at any point in another program or so on, as long as you've saved this this function we create here, price with tax func, somewhere. Although again, I did it in the work lib for this tutorial. Okay, so I think just based on the level it goes over the FCMP procedure. We've about covered it here with those bullets. Now we're going to move on to looking at some other functions, and I'll try and knock out a few of them in one data set. So we'll first start off by looking at these find functions, count functions, and the lag function. So we're going to look at another SAS help library data set called holiday, and I'll call my data set holiday 1, and then set SAS help dot holiday, and I'm going to make some different variables using these functions. So let's say I'm going to look yeah, so I'd use the find w function to see if so it's worth looking at this data set before I actually run this. Okay, let's just look at this real quick. So what I'll be referencing the desk column, which is this guy. So you see that desk column, okay. So it makes sense as I run through these. So contain, so the first variable I'm going to make in my holiday 1 work library data set is contain day position equals find w desk, and I'm going to look for day. And so just before I run the others, we'll take a look at what this column, this variable looks like, contain day position. So put a data, and R1 will be on the end, so contain day position, and it gives you, returns 8 for row 1 and then 23 for row 2. So we see that Boxing Day is 1, 2, 3, 4, 5, 6, 7, 8. That's where day starts, and then Canadian Independence Day is presumably at 23, as is Canadian Independence Day observed. So that's what we're returning. We're returning the position of this word using the find w function. Then, so let's run through some others and we'll look back at them at the end. So contain, I'm going to call this contain list position equals find C. And we'll do all of these on the desk column, the description column. I'm going to put Z, Y, X, W, semicolon. Then we're going to do count day. So I'm going to use the count function here as we keep on going through this list. Equals count locase. I'm going to use the locase function here of disk, and then day. Count list equals count C of, and just do lowercase desk, and might start copying and pasting just to speed this up a little bit, and then we'll run through what exactly we're doing here with these different functions. And then we're going to do, I'll call this one count words as we go to count W. Count words equals count W desk. And for last holiday, like the most recent holiday before the current one, I'm going to use the lag function, which is fairly straightforward to explain. It's if you're at the second row, you go back one row, essentially, in the data set. So, if we call this last holiday, I'll go to the previous, it'll be missing value for row one. Okay, so let's run this. So we just went through all those different functions in a data step. So we can sort of look at them now. So we're working on the desk column basically exclusively. So contain lists position. So that came from the find C desk. With the Z, Y, X, W. So we're looking for any of these list of letters or words. And so in our output data set, in the first row, we had contain list position free. So free, we had an X, so that's what popped up first. So we had an X, and then on the next one, I think it was 25 because we had a Y. Count day. So let's look at what the count function gives us. If there's any days where there's day in there twice, we'll have more than one, but it just returns one if there's day, and I guess in row 4, Christmas, it doesn't say day. Okay, so it returned a 0. So that's the count function. It's just sort of the gives you the count of a string within a string. And the count C gives us the number of hits of items in this list. So count the count list. So we got 2, 1. So we had 2 hits for X and Y in the first row, for example. Sorry, X and Y in the first row. This is count list. And then count words, we're just counting how many independent words there were in that string of desk. So Boxing Day has 2. You can look at that column. And last holiday was the lag function. So let's look at what the lag function does. So like I was saying, for the first row, it's missing, and then for Canadian Independence Day, the last holiday in this list. So they're not actually in sort of a chronological order actually, but the previous holiday in this list was Boxing Day, and so on, Canadian Independence Day. So the lag function is pretty useful, but I was just giving an example with this data set. Yeah, so I think I accidentally put 2 run statements in here. Okay, so let's move on to looking kind of as our finale, basic regx example here. Again, we'll use the we're looking at regular expression, pattern matching with the PRX function. And we'll look at these we'll look at some meta characters, and we'll just look at the function and call routines, PRX match, PRX parse, and PRX exchange. Okay. So I'm just going to type and then we'll go through the example after we've run it. So regex example. So set SAS help dot class. I'm just going to limit my observations to 6. So I'll set obs equals 6 with the data step option. I'm going to make a column called val2, and I'm going to make it length 1. So length val2 set to 1. Okay. So yep. Okay, so let's look at compiling a regex. So we'll call this re equals 1, and this is where we're going to use the PRX. So just copy it, PRX parse. So we're going to create a regular expression pattern in this line. We're going to use, so we're looking to match with the M. So we're going to do a regular expression that's designed to match any string that starts with 0 or more non-vowels. So that would look like this: A, E, I, O, U. Then a vowel. So we could do that with A, E, I, O, U. Then another non-vowel. So we're looking for this sort of pattern. And then another vowel. And gonna want a semicolon there. Okay, out one we're gonna want to have star between these and the other. Okay, so I think my syntax should work there. So this is us compiling the regex. Then we're gonna search for the match. So we're gonna use this re1. So we're going to use the PRX match function and the next part. So we'll make a column called start pause equals PRX match. PRX match, and this is a bit more straightforward. So it'd just be re1, the column we made up there, and name. That's from the SAS help class dataset. And we're going to use the PRX position function. So we'll call that val2. Which we define the length of up top. So prx posn and re1 comma 2 comma name. Okay. And then we can use the PR exchange function also to change the regular expression pattern. So let's use this. We'll use this on the age column. So re1 equals PR exchange. I'll just capitalize this to be consistent with the other functions. PR exchange, and I'll run through what we're doing here next. So not match set there. Let's see if we run into any errors. No errors. Cool. So let's look at what our output data set looks like. So we got this val2, and we have the start position column. We have the re1 column as well, which I think ends up being age. But yeah, let's just run through again what we're doing here. So the prx parse function is used to create a regular expression pattern here. The regular expression is sort of designed to match any string that starts with non-vowels, then has a vowel, then a non-vowel, then a vowel, and then we use prx match to search for a match of the pattern defined in this in prx parse in the name with and then the starting position is saved as a start pause column. So that's where we see start pause of 1. So start pause 1, and we have a start pause 0 for Henry. because he only has one vowel in his name, whereas all the other names have a second vowel. So that's what we get to in the val2 column, where we use the prx position function to extract the second capture of the match, which is the second vowel, which is found in the name. Okay, and then of course the PR exchange function is used to change the regular expression pattern for the age variable. This regular expression sort of changes the first occurrence of the pattern match in the age variable, but yeah, so we didn't actually change anything in this instance. Yeah, so our output data set contains all the original variables, and the additional val2 that contains the second val found, like we talked about, and the name variable and the age variable is modified by the PR exchange function down the bottom. So this is just a very brief introduction to regular expression pattern matching with these PRX functions. And yeah, I recommend just sort of playing around with this and looking up some of the other things you can do with regular expressions, and the various meta characters that you can use. So that concludes the entire tutorial here for the SAS Advanced Programmer. Especially with the section 3, it was some things that are a bit more obscure but could be touched on in the exam. So thanks for sticking around. Thanks again for following through and watching the entire video. I hope this helps you in preparing for the SAS 9.4 Advanced Programming performance-based exam. I also have a link below in the description to the first in a series of videos I did on the base programming certification. I did that video a couple of years ago, so there have been some changes, and I plan to do an update as soon as possible. But again, thanks for watching this video, and please feel free to check out some other videos on my channel. Good luck in the exam.